Right now, as you listen to this, you are sitting still. The chair holds you. The floor holds the chair. The ground holds the floor. Everything around you feels solid, fixed, certain. But it is not. Beneath you, the planet is turning at hundreds of miles an hour. The planet is racing around the sun. The sun is falling through the galaxy. And the galaxy is drifting through a void so large that the word large stops meaning anything at all. Feel still. You are not still. You never have been. Tonight, we are going to take a slow journey outward, away from your chair, away from your room, away from the earth, until the earth itself is too small to find. We will move one step at a time from the ground beneath you to the farthest edge of everything we can see. We'll pass the moon, the sun, the nearest stars, the giants that make our sun a speck, the galaxy that holds 400 billion suns, the clusters and superclusters, and the great cosmic web that strings it all together. And at the end, we will arrive at a number so vast it will press down on you like a weight. That number might make you feel like nothing. We will sit with that feeling, and then, gently, we will ask whether it is true. This is the kind of slow, careful journey you came for. Consider hitting like and subscribing. It helps more than you might think now. Let's begin. Start with where you are. Not the country, not the city, not the room. Start with the simple, physical fact of your body, sitting somewhere, held up by something, in this exact moment. You are warm, you are breathing. The air around you has a temperature, a smell, a weight you never notice. This is the most certain thing you know, that you are here now in this place. But hold that feeling of certainty for a moment, because we are about to test it. The place where you sit feels like the center of things. It always does. Every human being who has ever lived has felt themselves to be at the middle of the world, with everything else arranged around them. This is not arrogance. It is simply how it feels to be a conscious creature looking out from behind your own eyes. World radiates outward from you. You are the fixed point, and everything else is out there. This feeling is one of the oldest illusions our species has carried. For most of human history, people believed the earth was the still center of creation, with the sun, the moon, and the stars wheeling around it. It took thousands of years, and a great deal of courage, to accept that this is not true, that we are not at the center, that we are not still, that the ground beneath us is not the fixed floor of the universe, but a moving platform on a moving world in a moving galaxy. Consider how reasonable the old illusion was. Look around you right now. Does the ground feel like it is moving? The floor seemed to race through space. Of course not. Everything is calm, settled, fixed in place. Your senses tell you, with complete confidence, that you are sitting still on solid ground. And your senses are wrong. They are not lying, exactly. They are simply too small, too local, to detect the vast motions that carry you along. You cannot feel the earth turn, any more than a passenger feels a smoothly flying plane. So we begin here with you, on a rock in the dark. That is what the earth is. When you strip away the familiarity, a rock spinning in darkness, lit on one side by a nearby star. You live on its thin outer skin, in a film of air so shallow that if the earth were the size of an apple, the atmosphere would be thinner than the apple's peel. Below you is rock all the way down. Above you is a thin breath of air, and then nothing. And in that nothing, everything else waits. It is worth pausing on why this illusion is so powerful, so universal, so impossible to shake by intuition alone. Your senses evolved on the surface of this rock, to deal with the things that mattered for survival. The distance to a predator, the height of a cliff, the reach of an arm. They were never built to perceive the spin of a planet or the scale of a galaxy. The result is that everything in your direct experience confirms the illusion. The ground holds still. The sun appears to move across the sky, not the earth beneath you. The stars seem fixed to a dome overhead. Signal your body receives says, "You are still, you are central, the world is arranged around you." To learn otherwise, humans had to override their own senses with reason and measurement, to trust the numbers over the testimony of their eyes. That, in a way, is what this entire journey requires of you. Will not be able to feel most of what we are about to discuss. You cannot feel the spin of the Earth. And you certainly will not be able to feel the distance to a galaxy 2.5 million light years away. The numbers will be too large for any sensation. So we will lean, again and again, on comparisons and scale models and small concrete images. Ways of standing in for a comprehension the human mind cannot achieve directly. When a number defeats you, that is not a failure on your part. The journey we are about to take will move outward from this point, step by step. So we will not jump straight to the largest scales, because the mind cannot absorb them that way. Instead, we will climb a ladder, each rung larger than the last, each one stretching your sense of scale a little further. By the time we reach the top, the place where you sit, this certain central fixed point will have become something almost impossible to find. Speck on a speck on a speck, lost in a darkness without end. But that is the end of the journey. For now, stay here, in your body, in your chair. Feel the solidity of the ground. Notice how still everything seems. Hold on to that feeling, because it is about to dissolve. First thing we must do is look at the ground beneath you and see that it was never still at all. Ground beneath you feels like the very definition of stillness. We say solid ground to mean something that does not move, something you can count on. But this is one of the great deceptions of living on a planet. The ground beneath you is moving right now, in several different ways at once, at speeds that would terrify you if you could feel them. Start with the spin. The Earth turns on its axis once a day, and this turning is what gives us day and night. Think about what that turning actually means in terms of speed. The Earth is about 25,000 miles around at the equator, and it completes a full turn in 24 hours. That means a person standing at the equator is being carried eastward at over 1,000 miles an hour. Faster than a passenger jet, faster than the speed of sound. Even at the latitudes where most people live, the spin carries you along at many hundreds of miles an hour. Feel none of it. There is no wind in your face, no sense of motion, no blur. This is because everything around you, the air, the buildings, your own body, is moving at the same speed, all together, smoothly. Motion is only felt when something changes. When you speed up or slow down or turn, steady motion, shared by everything around you, is invisible to the senses. The 1,000-mile-an-hour spin of the Earth passes completely unnoticed. Every second of your life, but the spin is only the beginning. The Earth is also racing around the Sun, completing one great loop each year, to travel all the way around its orbit in a single year. The Earth must move at about 67,000 miles an hour. That is roughly 19 miles every second. In the time it takes you to read this sentence, you and the entire planet have moved hundreds of miles through space, swept along in the Earth's endless fall around the Sun. Again, you feel nothing because the motion is steady and shared. And even that is not the end. The Sun itself is not still. It orbits the centre of our galaxy, carrying the Earth and all the planets along with it, at a speed of about 500,000 miles an hour. The entire solar system is sweeping through the galaxy at this tremendous pace. And yet the journey is so vast that it takes the Sun something like 230 million years to complete a single orbit of the galaxy. the last time the sun was in its current position. Dinosaurs had not yet appeared on Earth. Pile these motions together, and the picture becomes dizzying. You are spinning at hundreds of miles an hour, orbiting the sun at tens of thousands of miles an hour, and sweeping through the galaxy at hundreds of thousands of miles an hour. All at the same time, all without the faintest sensation of movement. The stillness you feel is real to your senses, but false to the universe. You'd never been still for a single moment of your life. From the day you were born, you have been hurtling through space at speeds no machine on Earth can match. This is the first crack in the illusion of stillness, and it matters for the journey ahead. Because if your own ground, the most solid, certain thing you know, is in fact racing through space at unimaginable speed, then perhaps your other certainties about size and stillness and centrality are also illusions. Perhaps the smallness we are about to discover has been true all along, hidden only by the limits of what your body can feel. There is something almost vertiginous in this, if you let yourself feel it. Right now, as you sit reading or listening, perfectly still by every sense you possess, you are in fact moving in at least 4 ways at once. Spinning with the Earth, orbiting the Sun, circling the galactic center, and drifting with the whole galaxy through intergalactic space. Stack these velocities together, and you are hurtling through the cosmos at hundreds of thousands of miles an hour, in a direction not point toward a destination you will never reach. You feel nothing. The coffee in your cup sits flat. The air hangs still. Your body registers perfect rest. Gap between what is true and what you can feel has never been wider than it is in this very moment. So the ground was never still, and the rock you are standing on, racing through the dark, is itself far smaller than it feels. To see just how small, we have to leave it behind and look back at it from a distance. The Earth feels enormous. It is the whole world. Every place you have ever been, every person you have ever known, every event in all of human history, all of it contained on this single sphere. To us, the Earth is not just large, it is everything. The idea that it could be small seems almost absurd, and yet, the moment you step back from it, even a little, its true scale begins to reveal itself. The Earth is about 8,000 miles across. That is a large number by human standards. It would take many hours to fly from one side to the other, and most people never travel more than a tiny fraction of the planet's surface in their entire lives. The oceans are vast, the continents broad, the mountains high. From where you stand, the Earth stretches away in every direction farther than you could ever walk. It is, for all practical purposes, boundless. But large by human standards is a phrase that will keep failing us on this journey. And it fails for the first time right here. Because the moment you leave the Earth's surface and rise into space, the planet begins to shrink with astonishing speed. Astronauts in orbit, only a few hundred miles up, can already see the curve of the whole Earth, the thin blue line of the atmosphere, the roundness of the world. Rise a little higher, and the Earth becomes a globe you could cover with your thumb. There is a famous photograph taken from billions of miles away by a spacecraft leaving the solar system, in which the Earth appears as a single pale blue dot, a speck of light less than a pixel across, almost lost in a band of scattered sunlight. Everything that has ever happened to our species happened on that dot. Every empire, every war, every love story, every birth and death. All of it on a point of light so small that you could hide it behind a grain of dust held at arm's length. From the edge of the solar system, the Earth is not a world. It is a moat. Consider what this means. The Earth contains everything we have ever known, and yet from a distance that is, in cosmic terms, almost nothing. just the far edge of our own solar system. It has already shrunk to an invisible speck. We have not even left our own tiny corner of space. And already the whole of human experience has been reduced to a dot you could lose in an instant. And this is only the first rung of the ladder. The distances ahead make the edge of the solar system a marble, a mote, a dot, precious beyond measure. Because it is the only home we have and the only place we know of where there is life. But it is not large, it is not central. It is a tiny island of rock and water and air, adrift in a darkness so vast that the island vanishes almost the moment you step away from it. It is worth holding both of these truths together, because the rest of the journey depends on it. The Earth is at the same time almost nothing and absolutely everything. It is almost nothing in the cosmic sense, a speck that disappears from view at the edge of our own solar system, lost against the dark, and yet it is everything in the human sense. The only world we have ever known, the home of every living thing we have ever encountered, the stage of all history, as we travel outward and watch the Earth shrink toward invisibility. Do not let go of that second truth. The smallness we are uncovering does not make the Earth less precious. If anything, as we will see at the very end, it makes it more so, and the darkness around it is not empty in the way you might think. It is strung with other islands, other worlds, other suns. First of these, the one closest to us, is a familiar face in the night sky. To understand the distances ahead, we begin with the nearest thing to Earth in all of space, the moon. The moon is the most familiar object in the night sky. You have seen it 1,000 times, hanging low and golden on the horizon, riding high and silver overhead, waxing and waning through its phases. It feels close. It feels like a companion, a lamp in the dark, a face that looks down on us, and everything beyond the Earth. The moon is indeed the closest. It is our nearest neighbour in all of space. But even this nearest neighbour is far further away than your senses will ever let you feel. Moon looks small in the sky, about the size of a coin held at arm's length. This smallness, combined with its familiarity, makes it seem near, as if it hangs just above the clouds. But the moon is not just above the clouds. It is, on average, about 240,000 miles away. That number is so large that it is hard to hold in the mind. So let us make it concrete in the way that actually works, in terms of what could fit in the gap. Here is the fact that astonishes most people when they first hear it. The gap between the Earth and the moon is so wide that you could fit every other planet in the solar system into it, lined up side by side, and still have room to spare. Mercury, Venus, Mars, Jupiter, Saturn, Uranus, Neptune, all of them, all 7, fitted into the space between the Earth and its moon, with a gap left over. The moon is not hanging just overhead. It is 250,000 miles away, across a gulf wide enough to swallow the other worlds of the solar system. Think about this in terms of travel. Fastest passenger jets cross the distance from one side of the Earth to the other in less than a day. To reach the moon at that same speed, you would have to fly without stopping for nearly 2 weeks. The astronauts who went to the moon took 3 days to get there, travelling at speeds far greater than any aircraft. 3 days of continuous travel at thousands of miles an hour, just to reach the nearest object in the sky. That is the first real taste of cosmic distance. And it is the smallest taste we will get on this entire journey. And yet the moon is so close that it is the only other world human beings have ever set foot on. 12 people have walked on its surface. From the moon, the Earth hangs in the black sky. A blue and white marble 4 times wider than the moon appears to us, beautiful and small and alone. The astronauts who saw it described the strange feeling of seeing the entire world. everything they had ever known, as a single object they could cover with a raised thumb. The moon is close enough to visit, and even from there, the Earth already looks small. Let us put the moon's distance on our shrinking scale. Remember the Earth as a marble. On that scale, the moon would be a tiny pea, about a foot away from the marble. That is the Earth-Moon system. A marble and a pea, a foot apart, the only patch of space humans have ever physically crossed. Everything else on this journey, the sun, the planets, the stars, lies far, far beyond that 1 foot gap, crossed the distance to the pea. We have never crossed anything more. It is worth dwelling on that fact, because it puts the whole human adventure in space into perspective. We have built rockets and space stations, sent probes to the edge of the solar system, landed machines on Mars. It feels sometimes as if we have become a spacefaring species, as if the cosmos is opening up to us, measured against the true scale of things. Our reach is almost nothing. Farthest any human being has ever travelled from Earth is to the moon. 250,000 miles. The pea beside the marble. Everything beyond that, every planet and star and galaxy in this entire journey, lies in territory no human body has ever entered. We have dipped a single toe across the doorstep and called it exploration. The honest truth is that we have barely left home at all. So the moon gives us our first real sense of how distance works out here. That things which look close are staggeringly far, that the gaps between objects are wider than the objects themselves, that even our nearest neighbour lies across a gulf that could swallow worlds, and the moon is the near edge of distance. The next step takes us to the object that anchors everything in our sky, the fire at the centre of it all, and it lies hundreds of times farther away than the moon. Step outside on a clear day and look up, not directly at it, never directly at it, but in its direction. That blazing source of light and warmth, the thing that lights your whole world and makes life on Earth possible, is a star, our star. We call it the sun, and because it is ours, because it is familiar, we rarely think of it as what it truly is. A colossal ball of burning gas, a nuclear furnace so large that it makes the Earth look like a grain of sand beside a boulder. Sun is about 865,000 miles across. That number is hard to feel, so here is what it means. You could line up about 109 Earths across the face of the sun, side by side, and only just span its width. That is only across a single line. If you think about the sun's entire volume, the three-dimensional space it fills, the numbers become staggering. You could fit more than 1,000,000 Earths inside the sun and still have room left over. 1,000,000 Earths. Every human being who has ever lived, every creature, every ocean, packed into the sun 1,000,000 times over, and it would not be full. The sun is so large and so massive that it contains more than 99% of all the matter in the entire solar system. Everything else, all 8 planets, all the moons, all the asteroids and comets and dust, adds up to less than 1% of the total. The sun is not just the largest thing in our solar system, it is very nearly the only thing. Planets, including our Earth, are little more than crumbs left over from the sun's formation. Scraps of matter circling the great fire, and it is a fire, though fire is too small a word. At its core, the sun is fusing hydrogen into helium, crushing atoms together under unimaginable pressure and temperature, releasing energy in quantities that defy comprehension. Core of the sun reaches temperatures of around 27 million degrees. Every second, the sun converts millions of tons of its own matter into pure energy, and has been doing so for nearly 5 billion years, and will continue for billions more. Warmth you feel on your skin on a sunny day crossed 93 million miles of empty space to reach you. and it came from a furnace burning at the heart of our star. That distance, 93 million miles, is the next rung on our ladder, and it dwarfs everything before it. The moon was 250,000 miles away. The sun is nearly 400 times farther, on our shrinking scale, where the earth is a marble, and the moon a pea. A foot away, the sun would be a great glowing sphere the size of a beach ball, but it would sit the length of a football field away from the marble. The gap between the earth and the sun is so vast that light itself, the fastest thing in the universe, takes about 8 minutes to cross it. Hold on to that fact, because it is the key to everything that follows. Light is the fastest thing that exists. Nothing can outrun it. And yet light, leaving the sun, takes 8 full minutes to reach your eyes. This means that when you look at the sun, you are not seeing it as it is now. You are seeing it as it was 8 minutes ago. If the sun were to vanish in this instant, you would not know for 8 minutes. You would feel its warmth and see its light, blissfully unaware, until the last of the 8-minute-old light arrived and the sky went dark. The sun is a furnace that swallows 1,000,000 Earths, a fire so large that our entire world is a crumb beside it, and it lies so far away that its light reaches us already 8 minutes into the past. This is the scale of our own star, the nearest star to the Earth. And here is the thought that should begin to unsettle you. The sun is, by the standards of stars, completely ordinary. There are stars out there that would swallow the sun as easily as the sun swallows the Earth. Before we reach them, we must first understand the strange truth that the sun has already shown us. That to look out into space is to look backward in time. 8-minute delay is small, almost trivial, but it is the first hint of something that will grow as we travel outward, until we are looking back not minutes but billions of years. We have just met a strange and important idea, and before we go any further, we need to sit with it, because it changes the meaning of everything we will see for the rest of this journey. The idea is this: light takes time to travel. It is fast, almost unimaginably fast, but it is not instant. Because it takes time, everything you see in the sky is a picture of the past. Light travels at about 186,000 miles every second. In a single second, a beam of light could circle the Earth more than 7 times. It is so fast that here on the ground it seems instant. Flip a switch and the room is lit, with no delay you could ever notice. Distances of everyday life, light crosses the gap so quickly that the travel time is utterly invisible. This is why, for most of human history, people assumed light moved instantly, with no travel time at all. But space is not everyday life. Distances out there are so enormous that minutes to reach the Earth. So the sunlight warming your skin left the sun 8 minutes ago. You are not seeing the sun as it is. You are seeing the sun as it was a little while back. The present face of the sun is something you cannot see and never will. You can only ever see its past. Now extend this idea outward, because it only grows stranger. The moon is close, so its light reaches you in just over a second. You see the moon as it was about 1 second ago, which is near enough to now to feel real. Planets are minutes away at the speed of light. The nearest stars are years away. Distant stars you see, scattered across the night sky, are hundreds or thousands of years away. Faint galaxies, at the edge of what we can see, are billions of years away. When their light finally reaches your eyes, it has been travelling for almost the entire age of the universe. Think carefully about what this means. When you look up at the night sky, you are not seeing the universe as it is now. You are seeing a layered picture of the past, each point of light showing you a different moment in history, depending on how far away it is. The nearby stars show you a few years ago. The farther stars show you the time of ancient civilizations. The distant galaxies show you a time before the Earth existed, before the Sun existed, when the universe itself was young. The night sky is not a snapshot. It is a vast museum of different pasts, all hanging together in the same dark dome. Also means that some of the stars you see may no longer exist. A star 1,000 light years away shows you its light from 1,000 years ago. If that star died 500 years ago, its final light is still on its way to you. And you would go on seeing it, bright and steady, for another 500 years, never knowing it was already gone. The sky is full of such ghosts. Lights from stars that may have long since burned out, still shining for us across the gulf of time. We are watching a recording, not a live broadcast. There is something both haunting and beautiful in this. It means that to look out into space is to look back into time, and that the farther we look, the deeper into the past we see. Telescopes are time machines. The only way we can study the early universe is to look at the most distant objects, whose ancient light is just now arriving. We cannot see the universe's present. We can only ever see its past. Layer upon layer, stretching back almost to the beginning. Hold this idea close, because from here on, every single distance we cross is also a journey backward in time. When we reach the nearest stars, we will be looking years into the past. When we reach the edge of the galaxy, thousands of years. And when we reach the farthest galaxies, we will be gazing across almost the entire history of the cosmos. The size of the universe and the depth of time are, it turns out, the same thing seen from two sides. The next step outward, to the rest of our own solar system, already carries us light hours away from home. We have reached the Sun, 8 light minutes away, and we have learned that to look outward is to look into the past. Now let us widen our view to take in the whole solar system. The Sun and its family of planets, the patch of space we might call our own backyard. It is the only region of the universe that human machines have ever explored directly. And even it is far larger than most people imagine. Our solar system has 8 planets, circling the Sun at ever greater distances. Closest is Mercury, scorched and tiny, then Venus, wrapped in suffocating clouds. Then comes Earth, our home, the 3rd planet. Then Mars, the red world, the next target of human exploration. These 4 inner planets are relatively close together, all within a few light minutes of the Sun. If the solar system were only these 4 worlds, it would already be vast by human standards. But it is far, far bigger. Beyond Mars lies a great gap, and then the giant planets begin. Jupiter, the largest, is a world so big that all the other planets could fit inside it with room to spare. It is more than 1,000 times the volume of Earth. Then Saturn, with its magnificent rings, nearly as large. Then the more distant giants, Uranus and Neptune, cold and dim and far. These outer worlds are separated by enormous distances, not millions but billions of miles apart. The solar system is mostly empty space, with small islands of matter scattered across an immense darkness. To grasp the scale, think again in terms of light travel time. Light from the Sun reaches the Earth in 8 minutes, but light from the Sun takes more than 40 minutes to reach Jupiter, and about 80 minutes to reach Saturn. To reach Neptune, the most distant planet, sunlight must travel for more than 4 hours. The solar system is not 8 light minutes across, like the Earth's orbit. It is many light hours across, just to reach the outermost planet. Our backyard, it turns out, is light hours wide. This is why exploring the solar system takes so long. Spacecraft we have sent to the outer planets took years to arrive. Not because they were slow, but because the distances are so immense. Probe launched toward Jupiter or Saturn travels for years through the dark before it reaches its target. Probe that explored Pluto, out beyond Neptune, took nearly a decade to get there, travelling at tens of thousands of miles an hour the entire way. The solar system is so large that even at the speeds of our fastest machines, crossing it is the work of years. And consider what those probes saw on the way, which was mostly nothing. Between the planets lies vast empty space, almost perfectly dark and silent. Spacecraft crossing from one planet to the next spins years passing through emptiness, with the planets themselves no more than distant points of light for almost the entire journey. This is the first lesson the solar system teaches about the universe at large, that it is overwhelmingly empty. The objects, the planets, and later the stars and galaxies, are tiny islands separated by oceans of nothing. We tend to picture space as crowded with worlds, but the truth is the opposite. Space is mostly space. The matter is the exception. The emptiness is the rule. And it only grows more extreme as we travel outward. And yet, for all its vastness, the solar system is still just our backyard, the smallest meaningful unit on the cosmic scale. Everything we have ever touched, every world our machines have visited, every place within reach of human exploration, lies within this one small system. And, as we are about to see, the solar system does not end neatly at the last planet, fades outward, through ever emptier regions, until at last it dissolves into the space between the stars. The edge of our backyard is not a wall, it is a slow fading into the dark. Put the solar system on our shrinking scale one last time. If the sun were a beach ball at the centre of a city, the inner planets would be small marbles and grains within a few hundred feet. Jupiter and Saturn would be oranges a few city blocks away. Neptune, the outermost planet, would be a small marble more than a mile from the beach ball sun that is the size of our backyard. A beach ball at the centre, and a scattering of tiny worlds spread across a mile of empty space. Now hold that image, because the next object on our journey, the cloud that marks the true edge of the sun's domain, lies not a mile away on this scale, but hundreds of miles. When we picture the edge of the solar system, we usually imagine the orbit of the last planet, Neptune, or perhaps distant Pluto beyond it. But the sun's domain does not end there. Far beyond the planets, in the deep cold and darkness, lies a vast shell of icy objects that marks the true outer boundary of the sun's reach. It is called the Oort cloud, and its scale is so enormous that it forces us to redraw our entire picture of how big the solar system really is. Planets, even the most distant ones, orbit relatively close to the sun in the grand scheme of things, but surrounding the entire planetary system, far beyond Neptune. Astronomers believe there is an immense spherical cloud of icy bodies, the frozen leftovers of the solar system's formation, PUS. These are the objects that occasionally fall inward toward the sun and become the comets we see streaking across our skies. They spend most of their existence in the deep freeze of the outer solar system, unimaginably far from the sun's warmth. How far? This is where the numbers become difficult to hold. The inner edge of the Oort cloud is thought to begin thousands of times farther from the sun than the Earth is. The outer edge may extend to distances tens of thousands of times the Earth-Sun distance, or even more. We are no longer talking about light hours, as we were with the planets. We are talking about light that takes a year or more to cross the gap. The Oort cloud may extend as much as a full light year or more out from the sun in every direction. Let that settle. The planets lie within light hours of the sun, but the sun's true domain, marked by the Oort cloud, extends outward by perhaps a light year or more, a distance thousands of times greater. The planetary system is a beach ball with marbles scattered around it across a mile. The Oort cloud is a vast, faint shell surrounding the whole thing at a distance of hundreds of miles on that same scale, part of the solar system we usually think about. The planet's is a tiny core, lost inside a colossal sphere of darkness and ice. This matters for our journey, because the Oort cloud is what finally connects our solar system to the wider galaxy. Its outer edge reaches so far that it begins to approach the territory of the nearest other stars. The Sun's gravitational grip, which holds the Oort cloud in place, fades out at roughly the distance where the grip of neighbouring stars begins to take over. The Oort cloud is, in a sense, the frontier, the place where the Sun's kingdom finally ends and interstellar space begins. No human machine has ever crossed the Oort cloud. The spacecraft we have launched outward, the fastest objects we have ever built, the ones that have left the planets behind and are heading into interstellar space. Even they will take thousands of years just to reach the inner edge of the Oort cloud, and tens of thousands of years to pass through it. By the time they emerge from the far side into true interstellar space, human civilization, as we know it, may be long gone. The edge of our own solar system is so far away that we cannot reach it within the span of recorded history. Let that comparison land fully. We have spacecraft launched decades ago that have now travelled farther from Earth than any other human-made objects, and they are celebrated, rightly, as having reached interstellar space. But they have not even begun to cross the Oort cloud at their current speed. They will need something like 300 centuries simply to reach its inner edge. 300 centuries. 60 times the length of all recorded human history, just to arrive at the beginning of the Sun's outermost shell. The Oort cloud is still, by every measure, part of our own solar system. We have not left the Sun's domain. We are not close to leaving it. On the scale of the journey ahead, we have not moved at all. So the Sun's reach, when we trace it all the way out, is far larger than the orbits of the planets. A sphere perhaps 2 light-years across, marked at its edge by a faint cloud of ancient ice. And this entire vast domain, this whole kingdom of the Sun, is merely the setting for a single star. Because the next step on our journey takes us across the gulf to another star entirely. And that gulf is so wide that it makes the entire solar system look like a single point of light. We have now traced the full extent of the Sun's domain, all the way out to the faint, icy shell of the Oort cloud. Perhaps a light-year or more from the Sun, it is time to take the step that truly breaks the human sense of scale. The step to the next star, because the gap between our Sun and the nearest other star is so vast that everything we have discussed so far, the planets, the distances, the Oort cloud, collapses into insignificance beside it. The nearest star to our Sun is a small, dim red star called Proxima Centauri, part of a system of 3 stars known together as Alpha Centauri. It is our closest stellar neighbour, the nearest sun beyond our own, and it lies about 4¼ light-years away. 4¼ light-years. To everything we have seen, that number might not immediately land. So let us unfold it, because it is one of the most important numbers on this entire journey. A light-year is the distance light travels in a year, moving at 186,000 miles every second without stopping for a full year. That distance is about 6 trillion miles, 6,000 billion miles, and the nearest star is more than 4 of those, over 25 trillion miles away. The number is so large that writing it out, or trying to picture the miles, is useless. The human mind simply cannot hold a number like 25 trillion in any meaningful way. We need a different approach. So return to our shrinking scale, the one where the Sun is a beach ball. Remember that on that scale the Earth was a marble the length of a football field away. and the whole planetary system was a scattering of small objects across a mile. On that very same scale, Sun as a beach ball, where would the nearest star be? It would be another beach ball, and that other beach ball would sit not a mile away, not 100 miles away, but thousands of miles away. On the other side of a continent, two beach balls, representing two stars, separated by the width of a continent, with almost perfectly empty space in between. This is the truth that the night sky hides from us. When you look up and see the stars as scattered across the dark, they look close together, like a handful of jewels thrown onto black velvet, all at roughly the same distance, all near one another, but they are not. Each one is a sun, like ours, and the gaps between them are so enormous that light itself takes years to cross from one to the next. Stars are not a crowd, paused. They are scattered across a vastness, so empty that each one is utterly alone, separated from its neighbours by trillions of miles of nothing. And remember what the distance means in time. Proxima Centauri is over 4 light-years away, so the light you see from it left the star more than 4 years ago. You are seeing it as it was 4 years in the past, and this is the nearest star. The light from most stars you can see in the night sky left them long before you were born. Some before any living person was born. Some in the time of ancient empires. To look at the stars is to look across both unimaginable distance and unimaginable time at once. To reach even this nearest star with our fastest current spacecraft would take tens of thousands of years. There is no machine we can build today that could carry a human being to another star within a lifetime or within many lifetimes. Gulf is simply too wide. We have crossed the distance to the moon, a marble and a pea, a foot apart. The nearest stars is a second beach ball on the far side of a continent. Between those two scales lies the difference between what we can reach and what we may never reach. So the nearest star is far farther than you can feel, farther than you can picture, farther than any human journey could ever cross. And it is the nearest one of all. The galaxy that contains it holds hundreds of billions of stars, scattered across distances that make the gap to Proxima Centauri look like a single step. Before we widen out to the galaxy, we need to make this enormous unit, the light year, feel as real as we can, because we are about to use it thousands, millions, and then billions of times over. And if the unit stays abstract, every number that follows will slip away from us like water. Light year is the unit we will use for the rest of this journey. Every distance from here outward will be measured in light years. First single ones, then thousands, then millions, then billions. So before we go further, we need to make absolutely sure this unit is real to you. Because the word itself is deceptive. It sounds modest. It sounds almost small, and it hides one of the largest distances the human mind has ever tried to grasp. The deception is in the word year. A year feels familiar and manageable. We live through them one after another. Year is a birthday, a season cycle, a unit of ordinary life. So, light year can sound like a comfortable human-sized measure, as if it were merely a long distance, the kind you might drive in a very long trip. This is completely wrong. And the wrongness matters, because if you let the word fool you, every number that follows will lose its weight. Here is what a light year actually is. Light moves at 186,000 miles every second, not every hour, every second. In 1 second, light travels far enough to circle the Earth more than 7 times. Now let that continue, second after second, for a full minute, then an hour, then a day, then a month, then an entire year. The distance that light covers in that year, never slowing, never stopping, is 1 light year. It comes out to about 6 trillion miles, 6,000 billion miles. Let us try to make 6 trillion real. even though the mind resists it. If you tried to count to 6 trillion, one number per second, without ever stopping to sleep or eat, it would take you nearly 200,000 years. The entire span of human civilization, from the first cities to today, is only a few thousand years. Would have to count, without pause, for 40 times length of all recorded history, just to reach the number of miles in a single light year. And the nearest star is over 4 light years away. The galaxy is 100,000 light years across. The farthest things we can see are billions of light years away. This is why the word hides the truth. 100,000 light years sounds like a phrase you can understand, because the words are familiar, but what it actually describes is 100,000 times 6 trillion miles. A number with so many zeros that it has no meaning to the human mind at all. We say these numbers easily, almost casually, but they describe distances that no human intuition can hold. The light year is a tool that lets us write the numbers down, but it does not let us feel them. Nothing lets us feel them. They are simply too large, and yet there is a strange gift hidden in the light year, the same gift we found earlier, because light takes time to travel. A distance in light years is also a distance in time. Star 10 light years away is seen as it was 10 years ago. Galaxy 1,000,000 light years away is seen as it was 1,000,000 years ago. Galaxy 10 billion light years away is seen as it was 10 billion years ago, long before the Earth existed. So every light year of distance is also a year of looking into the past. The unit measures space and time together, woven into one. This doubling, that distance is also time, is not a quirk or a curiosity. It is one of the most profound features of the universe, and it will deepen as we travel outward. When we reach the nearest stars, we will be looking a few years into the past. When we reach the giant stars, centuries. When we cross to the nearest galaxy, we will be looking back millions of years to a time before our species existed. And when we reach the farthest galaxies at the edge of the observable universe, we will be looking back billions of years, almost to the beginning of time itself. The light year, then, is not merely a ruler for measuring space, it is also a clock, running backward, carrying us deeper into the past with every step we take outward. To map the size of the universe is, unavoidably, to map the depth of its history. This is the unit we now carry with us. From here, the journey leaves behind the comfortable scales of planets and nearest stars, and moves into distances measured in thousands and millions and billions of light years. Each step will stretch the number further past what you can hold. Do not try to picture the miles. You cannot, and neither can anyone. Instead, hold on to the comparisons, the counting, the scale models, the time travel, and let them stand in for a comprehension that is simply beyond us. With a light year in hand, we are ready to widen out from the nearest star to the swarm of stars around us, and then to the great whirlpool of suns we call home. Crossed the gulf to the nearest star, and we have made the light year as real as it can be made. Host. Now let us lift our view a little higher, to take in not one neighbouring star, but the whole local neighbourhood of stars around our sun, because the sun does not sit alone in space. It is one star among many in a particular region of the galaxy, surrounded by other suns at distances of a few to a few dozen light years. This neighbourhood is the next rung on our ladder. Hunt. Within about a dozen light years of the sun, there are a handful of stars, perhaps a couple of dozen, depending on how you count the dim ones. Some are familiar names to astronomers. Alpha Centauri, the nearest system. Barnard's star, a fast-moving red dwarf. Sirius, the brightest star in our night sky, which lies less than 9 light years away. These are our stellar neighbours, the suns closest to our own. Even within this small neighbourhood, The distances are enormous. Every one of these stars is trillions of miles from the Sun and from each other. Most of these neighbouring stars are far dimmer than our Sun. The galaxy is dominated not by bright sun-like stars, but by small, faint red dwarf stars, cool, dim, long-lived suns that are difficult to see even when they are relatively close. Many of the stars in our immediate neighbourhood are these faint red dwarfs, so dim that none of them are visible to the naked eye, despite being among the closest stars to Earth. The night sky we see is a biased sample, showing us mainly the rare bright stars and hiding the far more numerous dim ones. This is worth pausing on, because it changes the picture of the sky. When you look up at night, you might see a few thousand stars with the naked eye, under perfect conditions. Feels like a lot. But those few thousand stars are almost all unusually bright and relatively nearby, the standouts in our local region of the galaxy. For every bright star you can see, there are many more dim ones you cannot, hidden in the darkness between. Visible stars are the tip of an iceberg. The galaxy holds vastly more stars than any human eye has ever seen. Let us place the neighbourhood on a scale. If we shrank things down so that the distance from the Sun to the nearest star over 4 light-years were a single step, then the local neighbourhood of stars would be a region a few dozen steps across. Within that region, a couple of dozen suns drift, each separated from the others by at least one of those enormous steps. The neighbourhood is mostly empty space, with stars scattered thinly through it, like a few grains of sand spread across a large, dark room. And here is the humbling part. This neighbourhood, the few dozen stars within a dozen or so light-years of the Sun, is an almost invisibly small patch of the galaxy. The galaxy is 100,000 light-years across. Our neighbourhood, a couple of dozen light-years wide, is a speck within it, the way a single house is a speck within an entire continent. Paused. We have widened our view from one star to a couple of dozen, and we have not even begun to approach the scale of the galaxy. The local neighbourhood is just the first small clearing in a forest of 400 billion trees. It helps to make that comparison exact. If the Milky Way were shrunk to the size of a continent, our entire local neighbourhood of stars, every sun within a dozen light-years of us, would fit under a single fingernail pressed against that continent. A few thousand stars you can see with the naked eye on the darkest night. All of them are crowded into that same tiny patch, thing that has ever been a star to human beings. Every point of light named by every culture, every constellation drawn across every sky in history, lies within this fingernail-sized region of an entire continent-sized galaxy. The night sky, for all its apparent depth, is in truth an extremely local view, a glimpse of our own immediate doorstep, with the vast bulk of the galaxy lying far beyond anything the unaided eye can reach. Before we step back to see that whole forest, there is one more thing to understand about the stars around us. They are not all alike. Some of them are not modest suns like ours, but monsters. Stars so large that our sun would be a speck beside them. Truly feel our smallness. We need to look not just at how far the stars are, but at how large some of them can be. And the first of these giants is a star you can find in the sky tonight. Spent some time feeling how far away the stars are. Now let us feel how large they can be. Because our sun, that furnace that swallows 1,000,000 Earths, is itself a modest star, and there are suns out there beside which the sun is a speck. To begin to grasp this, look up on a clear winter night and find the constellation Orion, the hunter, one of the most recognizable patterns in the sky. Look to the upper left corner of Orion and find the bright star with a faint reddish tint. That star is Betelgeuse, and it is a giant. Betelgeuse is what astronomers call a red supergiant, an old dying star that has swollen to enormous size as it nears the end of its life. It lies about 700 light-years away, so the reddish light you see from it tonight left the star 700 years ago, in the time of the late Middle Ages. Despite that enormous distance, Betelgeuse is one of the brightest stars in our sky because it is so staggeringly large and luminous. It is not large the way the sun is large. It is large in a way that breaks the scale entirely. Here is what Betelgeuse's size actually means. Sun is about 865,000 miles across, large enough to swallow 1,000,000 Earths. But if you took Betelgeuse and placed it where the sun sits, at the centre of our solar system, its surface would not stop at the Earth's orbit, would engulf the orbit of Mercury, then Venus, then the Earth, then Mars, swallowing all 4 inner planets, and keep expanding outward past the asteroid belt until its surface reached somewhere near the orbit of Jupiter. The entire inner solar system, including the Earth, would be inside the star. Sit with that image, everything from the Sun out to Jupiter. The whole region that contains our world and all the inner planets would fit inside Betelgeuse, with the Earth buried deep within the star's glowing body. Sun beside Betelgeuse would be a tiny point, almost invisible. If the Sun were a grain of sand, Betelgeuse would be a sphere larger than a room, the star we depend on for all life. The furnace that dwarfs our Earth is itself dwarfed beyond comprehension by this single dying giant in the shoulder of Orion. Betelgeuse is not even the largest. It is simply one of the nearest and most visible of the giant stars, close enough to see with the naked eye. There are stars far larger still scattered through the galaxy. Hypergiants so vast that even Betelgeuse would be small beside them. We will reach those in a moment. Betelgeuse is the perfect starting point, because it is real, it is visible, and it is up in the sky tonight. A giant you can find with your own eyes, its ancient light arriving after a 700-year journey across space. There is something else remarkable about Betelgeuse. It is old, and it is dying. A star like this, near the end of its life, is destined to explode, to collapse and detonate as a supernova, one of the most violent events in the universe, briefly outshining entire galaxies. Astronomers expect Betelgeuse to explode at some point. Though some point could mean tonight, or could mean 100,000 years from now. Because the star is 700 light-years away, if it has already exploded, if it detonated, say, 500 years ago, we would not yet know. The light of its death would still be crossing the gulf toward us, and Betelgeuse would still hang in Orion's shoulder, looking alive, a star that might already be a corpse. Betelgeuse does explode. Whenever its light finally reaches us, it will be one of the great spectacles in the history of human skywatching. For weeks, it will blaze so brightly that it will be visible in broad daylight, outshining everything in the night sky but the moon, casting faint shadows on the ground at night. And then, over months, it will fade, until the familiar shoulder of Orion goes dark, and the constellation is changed forever. Somewhere out there, that light may already be on its way. We simply cannot know. Vast distances mean that even the death of a nearby giant reaches us only as old news, delayed by centuries. A message still in transit across the dark. Betelgeuse gives us our first true sense of how large a single star can be. Large enough to swallow our entire inner solar system, large enough to make our life-giving sun a speck, points the way toward something even more staggering. 'Cause if a star can be this large, the question naturally follows. How large can a star get? What is the biggest sun in the universe? And what does our sun become beside it? That is where we turn next. And the answer will shrink our sun almost to nothing. Betelgeuse showed us a star large enough to swallow our inner solar system. Betelgeuse is not the largest star known. There are suns out there so vast that even Betelgeuse would be a modest object beside them. And beside these true giants, our sun shrinks from a speck to a pinhead, from a pinhead to something almost too small to find. To understand our place, we have to follow the scale of stars all the way to its upper limit. Astronomers measure the largest stars in units of the sun's radius, the distance from the sun's centre to its surface. Our sun is one solar radius by definition. Betelgeuse is several hundred solar radii across, which is what allows it to swallow the inner planets. The largest known stars push far beyond even that. Biggest stars yet discovered stretch to well over 1,000 solar radii. Some past 2,000. A star of 2,000 solar radii is 2,000 times wider than our sun. Try to picture what that means. Placed one of these hypergiants where the sun sits, its surface would extend not just past Jupiter, as Betelgeuse would, but far beyond, past Saturn, out toward the orbits of the most distant planets. The entire region where the planets orbit, the whole core of our solar system, would be deep inside a single star, light, which takes 8 minutes to cross from the sun to the Earth. Would take hours, just to travel from the centre of such a star to its surface. Single star, larger than the orbits of the planets. Now put our sun beside it. One of these largest stars were the size of a sports stadium. Our sun, on that same scale, would be a pinhead sitting in the middle of the field. A tiny dot, almost invisible, lost in the vastness of the star around it. The sun, which swallows 1,000,000 Earths, which contains 99% of our solar system's matter, becomes a pinhead, and the Earth beside that pinhead would be a speck of dust, too small to see at all. This is the chain of smallness we are climbing, each link making the last one tinier. It is worth holding all three scales in mind at once, because together they tell the story. The Earth is a marble. The sun is a beach ball that swallows 1,000,000 such marbles, and the largest stars are stadiums that would swallow our beach ball sun 2,000 times over in width alone, and countless times over in volume, from the Earth to the sun to the hypergiant. Each step is a leap so large that the previous object nearly vanishes, and we are still only talking about single stars, individual suns within our own galaxy. These giant stars are rare, and they do not live long. Star that large burns through its fuel at a furious rate, shining millions of times more brightly than the sun, and so it lasts only a few million years before exhausting itself and exploding. They are brief, brilliant, and enormous, the flared final stages of the most massive stars. While they exist, they are the largest single objects of their kind in the universe, and they put the scale of our own sun into brutal perspective. Sun is not just small compared to the galaxy or the universe. It is small compared to other stars. Yet, here is a turn worth pausing on. Being large is not the same as being significant, even among stars. These hypergiants, for all their staggering size, are fleeting. They flare into existence, burn through their enormous fuel in a cosmic instant, and destroy themselves in a few million years. Our modest sun, by contrast, will shine steadily for 10 billion years, long enough for life to arise on a planet circling it, and evolve into beings capable of looking up and measuring the giants. The largest stars are spectacular and brief. The smaller, steadier stars are the ones that endure, the ones around which life has the time to take hold. Even here, at the scale of stars, the relationship between size and importance turns out to be far less simple than it first appears. A hint of something we will return to at the very end of this journey. So we have followed the scale of stars to its limit and watched our sun shrink to a pinhead. But here is the thing to hold on to. All of these stars, our sun, Betelgeuse, the largest hypergiants, every star you have ever seen or heard of, are members of a single structure. They all belong to one galaxy, our galaxy, a vast wheeling city of stars. And the number of stars in that city is so large that it dwarfs everything we have discussed. It is time to step back and see the whole forest at once, the Milky Way. We have spent this whole journey among individual stars. Our sun, the nearest stars, the giants. Now, it is time to step back far enough to see the structure that contains them all. Our galaxy, the Milky Way. This is the great whirlpool of stars that is our home in the largest sense. And its scale is so far beyond the distances we have discussed that we must reset our minds entirely to take it in. On a truly dark night, far from any city lights, you can see the Milky Way with your own eyes. A faint pale band of light stretching across the sky, like a river of mist or a trail of spilled milk, which is where the name comes from. For most of human history, no one knew what that band of light truly was. Now we know. That pale river is the combined glow of countless distant stars, so far away and so numerous that they blurred together into a soft haze. You are seeing our galaxy from the inside, edge on, looking out through the disk of stars in which we are embedded. The Milky Way is a spiral galaxy, a vast, flattened, rotating disk of stars, with great curving arms winding outward from a dense central bulge. And the number of stars it contains is staggering. Our galaxy holds somewhere between 200 billion and 400 billion stars. The number is so large that astronomers cannot even count it precisely. They estimate it, and the estimate spans hundreds of billions. Think about that. Our galaxy is so vast, Dad, that we cannot pin down how many suns it holds to better than a couple of 100 billion either way. Every one of those hundreds of billions of stars is a sun. Many of them, we now know, have planets of their own. So the galaxy contains not just hundreds of billions of stars, but likely a comparable number of worlds, perhaps more. Every story we have told on this journey, the sun, the planets, the giants like Betelgeuse, is repeated with endless variation hundreds of billions of times across the galaxy. Each star is its own solar system, its own centre, its own small kingdom of light in the dark, and there are hundreds of billions of them. The size of the galaxy matches the number of its stars. The Milky Way is about 100,000 light-years across. Remember what a light-year is. 6 trillion miles. A distance you could not count to in 40 times the length of human history. Now multiply that by 100,000. That is the width of our galaxy. Light. The fastest thing in the universe takes 100,000 years to cruise from one side of the Milky Way to the other. If you shone a beam of light across the galaxy, it would not reach the far side until 100,000 years had passed. Longer than our species has existed in its modern form, let us make the galaxy concrete one more way. Imagine shrinking the entire Milky Way down until it was the size of a continent, say the size of North America. On that scale, our sun, with its whole solar system, would not be a city, not a town, not even a building. It would be smaller than a single grain of sand. The distance to the nearest star, that gulf so wide it takes light 4 years to cross, would be a tiny fraction of an inch. The entire neighbourhood of stuff we discussed would fit under your fingernail. The galaxy itself, holding all of it, would span a continent. That is how small we are within our own galaxy. So the Milky Way is a city of 400 billion suns, 100,000 light-years wide, and we are a single grain of sand within it. One star among hundreds of billions, in one small corner of one spiral arm, climbed from the Earth to the Sun, to the giants, to the galaxy. And at each step, The previous scale has nearly vanished. And yet, astonishingly, we are still near the very beginning of the journey. Galaxy feels like it should be the end. It contains everything we have discussed. Every star, every distance, the whole of the night sky. But the galaxy itself, vast as it is, turns out to be just one of an almost unthinkable number, scattered across a cosmos so large that the Milky Way becomes a single point of light within it. First, let us feel our place within this one galaxy a little more deeply, because even within our own galactic home, our position is humbler than you might expect. We have seen that the Milky Way holds hundreds of billions of stars across 100,000 light years, and that our Sun is a single grain of sand within it. But it is worth slowing down here, because the smallness of our position inside our own galaxy is something that deserves to be felt, not just stated. Where exactly are we in this great city of suns? What does our location tell us about how small and how ordinary our place truly is? We are not at the centre of the galaxy. For a long time, people might have hoped or assumed that our sun sat somewhere special, near the middle, perhaps, where the action is. It does not. Our sun lies far out in the suburbs of the Milky Way, roughly 26,000 light-years from the galactic centre, in a relatively quiet region between two of the great spiral arms. We are not in the bright crowded core. We are out in a thinly populated outer district, one ordinary star among the billions scattered through the galaxy's outskirts. Consider what that distance means, the centre of our own galaxy. The heart of the structure we live in is 26,000 light-years away. The light arriving from the galactic centre right now left it 26,000 years ago, when the last ice age still gripped the Earth and humans were painting on cave walls. We cannot see the centre of our own galaxy as it is now. We can only see it as it was in the depths of the Stone Age. That is how far we sit from the middle of our own home, and our position is not just distant from the centre, it is utterly unremarkable. There is nothing special about the Sun's location in the galaxy. It is not the brightest region, not the densest, not the oldest or the youngest. It is an average spot in an average spiral arm, the kind of place that is repeated countless times throughout the galaxy. If you were a traveller surveying the Milky Way from outside, looking for something notable, you would have no reason to give our location a second glance. It is one quiet suburb among hundreds of billions of stellar homes. This ordinariness is itself a profound discovery. Throughout history, humans assumed we were central, special, located at the heart of things. The journey of science has been in large part the slow dismantling of that assumption. First we learned the Earth is not the centre of the solar system. Then we learned the Sun is not the centre of the galaxy. Now we know our Sun is an ordinary star in an ordinary place, far from any centre, one of hundreds of billions, in a galaxy that is itself, as we are about to see, one of an almost unthinkable number. Every scale, we are not the centre. We are somewhere off to the side, small and unremarkable. Let us hold the full chain of smallness we have built so far. You are a person's on the Earth. The Earth is a marble beside a beach ball sun. The Sun is a pinhead beside the largest stars, and the Sun, with all its planets, is a single grain of sand in a galaxy the size of a continent, located far out in the unremarkable suburbs, 26,000 light-years from a centre we can only see as it was in the Stone Age. Each layer of this picture makes us smaller. And we are not finished. We have not yet left the galaxy. There is a deeper humility hidden in this ordinariness, and it is worth naming directly. For most of human history, the assumption of our own centrality was not just a mistake about astronomy. It was woven into how we understood our place in existence. We were the centre, and so we mattered. The heavens turned around us, and so we were the point of it all. Science has slowly, patiently dismantled every part of that assumption. We are not at the centre of the solar system, nor of the galaxy, nor, as we will see, of anything at all. And yet, strangely, this dismantling has not diminished what we have discovered. It has expanded it. The more we accepted our smallness, the more of the true universe we were able to see. Price of understanding the cosmos. The price of understanding the cosmos was giving up the comforting illusion that it revolved around us. It is a trade that has enriched us beyond measure, even as it has humbled us beyond words. Because the Milky Way, for all its hundreds of billions of stars, is not alone. It has neighbours, other galaxies, drifting in the dark, some of them on a collision course with us. To continue the journey outward, we must leave our own galaxy behind entirely and cross the immense gulf to the next one. And the nearest large galaxy, it turns out, is already falling toward us through space. Before we leave the Milky Way behind, we should look toward its centre, because something extraordinary lurks there, anchoring the entire galaxy, and it adds another dimension to our sense of scale and smallness. The heart of our galaxy, 26,000 light-years away, sits an object so dense and so massive that it bends the very fabric of space and time around it. It is a supermassive black hole, and it is the gravitational anchor of our galactic home. Black hole is a region where matter has been compressed so completely that its gravity becomes inescapable, so strong that nothing, not even light, can escape from within it. Black hole at the centre of the Milky Way is not a small one. It contains the mass of about 4 million suns, all crushed into a region smaller than the orbits of the inner planets. 4 million suns worth of matter, compressed into a single dark point at the centre of our galaxy. It is called Sagittarius A star, and it is one of the most extreme objects in our cosmic neighbourhood. Everything in the galaxy, including our own sun, orbits around this central mass. The entire Milky Way, all 400 billion stars, wheels slowly around the galactic centre, held together in part by the gravity of this monster and the vast halo of matter surrounding it. Our sun, far out in the suburbs, takes about 230 million years to complete a single orbit of the galactic centre. We are, all of us, slowly circling a black hole, carried along on a journey so vast that one lap takes longer than the time since the first dinosaurs. For a long time, the existence of this black hole was inferred, but not seen. Black holes, by their nature, emit no light, so they cannot be photographed directly. But astronomers watched the stars near the galactic centre and saw them whipping around something invisible at tremendous speeds, orbiting a point of enormous mass that gave off no light. The only explanation was a supermassive black hole pond. And eventually, by combining telescopes across the entire Earth, astronomers managed to capture an image of the glowing matter swirling around it. A picture of the shadow of the monster at the heart of our galaxy. What does this add to our sense of scale? Tells us that even the centre of our galaxy, the place we might imagine as a bright, crowded hub, is dominated by an object of almost incomprehensible extremity. A gravitational pit 4 million times the mass of our Sun. Our entire galaxy, the city of 400 billion suns, is organised around this single dark anchor. And we orbit it from far out in the suburbs, one grain of sand among billions, circling a monster we cannot see, on a journey that takes 250 million years per lap. There is something humbling in this. Tend to think of our sun as powerful, dominant, the ruler of its little kingdom of planets. And within our solar system, it is. But our sun is itself a subject, bound to the gravity of the galactic centre, circling endlessly around a black hole millions of times more massive than itself. The sun rules its planets, but it is ruled in turn by the monster at the galaxy's heart. Every scale, the thing that seemed dominant turns out to be small, subordinate, caught in the grip of something far larger. It is worth sitting with the strangeness of what lurks at the centre. A black hole is not simply a very dense object. It is a place where the rules of ordinary space and time break down entirely. At its boundary, the pull of gravity becomes so strong that escape would require travelling faster than light, which nothing can do. And so nothing escapes. Not light, not matter, not information. Anything that crosses that boundary is gone from our universe forever, crushed toward a centre where our understanding of physics simply fails. And our entire galaxy, all 400 billion stars, wheels in stately orbit around this point of no return, this tear in the fabric of reality. We live in the suburbs of a structure organised around an abyss. It has been there far longer than the Earth, and it will remain long after the sun has died. We are, all of us, in slow orbit around the dark. So the galaxy has its dark anchor, and we orbit it from the distant suburbs. We have now explored our galactic home thoroughly. Its stars, its scale, our place within it, the monster at its heart. It is time to take the largest step yet, the step that truly leaves home behind. We must cross the gulf between galaxies, out into the space where the Milky Way itself becomes just one island among many. And the nearest of those other islands is already rushing toward us. We are about to leave the Milky Way behind and cross into intergalactic space, the vast darkness between galaxies. First stop is the nearest large galaxy to our own, a great spiral, much like the Milky Way, called Andromeda. It is the most distant object that the human eye can see without a telescope. A faint smudge of light in the night sky, and understanding it stretches our sense of scale to a new level entirely. Very dark, clear night. If you know exactly where to look in the constellation of Andromeda, you can see it. A small, faint, fuzzy patch of light, no brighter than a dim star, easily mistaken for a smudge or a cloud. Faint smudge is the Andromeda galaxy. Here is the staggering thing about it. That dim patch of light is not a star, not a cloud, but an entire galaxy, a vast spiral containing perhaps 1,000,000,000,000 stars, even more than our own Milky Way. When you look at that faint smudge, you are looking at 1,000,000,000,000 suns, blurred together by distance into a single dim glow. How far away is it? Andromeda lies about 2.5 million light-years from us. Let that number register against everything we have built. The nearest star was 4 light-years away. The galaxy is 100,000 light-years across, but Andromeda is 2.5 million light-years away. 25 times the width of our entire galaxy. The light you see from that faint smudge tonight left Andromeda 2.5 million years ago, long before modern humans existed, when our ancestors were early, primitive forms just beginning to walk upright on the plains of Africa. Think about what it means to see something so far away with your naked eye. The light from Andromeda travelled across 2.5 million light-years of empty intergalactic space, a gulf so vast it dwarfs the entire Milky Way. And at the end of that 2.5 million year journey, a few particles of that ancient light entered your eye and were detected. You are, in the most literal sense, seeing across millions of years and millions of light-years with nothing but your own eyes. The faintest smudge in the night sky is a window onto a whole other galaxy, seen as it was before your species existed. Here is the part that surprises people most. Andromeda is not sitting still at that distance. It is moving, and it is moving toward us. Most galaxies in the universe are racing away from us as space expands. But Andromeda is close enough that gravity overrides the expansion, pulling it and the Milky Way together. Andromeda is falling toward our galaxy at about 250,000 miles an hour. Two great spirals are on a collision course, destined to meet and merge billions of years from now in a slow cosmic collision that will eventually blend them into a single larger galaxy. That collision is far in the future, about 4 to 5 billion years away, around the same time our sun begins to die. When it happens, the two galaxies will not crash like solid objects. The stars are so far apart that almost none will actually collide. Instead, the galaxies will pass through and around each other over hundreds of millions of years, their shapes torn and reshaped by gravity, until they finally settle into one. No one will be here on this earth to see it. But it is coming, written into the motions of the two galaxies, an appointment set billions of years in advance. Pause on that detail, because it captures the strangeness of cosmic scale better than almost anything. Two galaxies, each containing hundreds of billions of stars, will collide. And yet almost no stars will hit each other. The reason is the emptiness we keep returning to. The stars within a galaxy are so tiny, and the distances between them so vast, that two galaxies can pass straight through one another, and the individual suns will simply glide past. Like two swarms of gnats merging in a vast field, with hardly a single collision. Galaxies will be reshaped, their spiral arms torn into long streamers, and eventually merged into a single great elliptical cloud of stars. But the stars themselves, including any worlds that circle them, will mostly survive untouched, rearranged, but not destroyed. That is how empty a galaxy is. So Andromeda gives us our first true sense of the scale between galaxies. 2.5 million light-years to the nearest large one, 25 times the width of our own galaxy, and yet close enough to see by eye, and close enough to be falling toward us. But Andromeda and the Milky Way are not alone in their little corner of the universe. They are members of a small cluster of galaxies, bound together by gravity, drifting through space as a group. To continue outward, we must zoom back again and see our galaxy not as a whole, but as one island in a small archipelago, crossed the gulf to Andromeda, 2.5 million light-years away, and learned that galaxies come in groups. Now, let us zoom out far enough to see our own group whole. Because the Milky Way and Andromeda are not solitary. They are the two largest members of a small cluster of galaxies bound together by gravity, drifting through the universe as a unit. This cluster is called the local group, and it is the next rung on our ever-widening ladder. The local group contains the Milky Way, Andromeda, and a third spiral galaxy called the Triangulum Galaxy, plus several dozen much smaller galaxies, mostly dim dwarf galaxies, that orbit the two big spirals like moons around planets. In total, the local group contains more than 50 galaxies, though the vast majority are small and faint, clustered around the two dominant spirals. It is, by cosmic standards, a modest gathering. A small town of galaxies, not a great city. The local group spans about 10 million light-years across. Pause on that. We have moved from a galaxy 100,000 light-years wide to a group of galaxies 10 million light-years across, 100 times wider. Within this span, more than 50 galaxies drift, each one containing millions, billions, or in the case of the great spirals, hundreds of billions, or even 1 trillion stars. The local group is a collection of galaxies, and each galaxy is a collection of hundreds of billions of suns. The numbers are now compounding beyond any hope of intuition. Let us try to hold the new scale. If we shrank the Milky Way down to the size of a dinner plate, then Andromeda would be another, slightly larger dinner plate, sitting a few feet away. Smaller galaxies would be scattered crumbs and grains around the two plates, and the whole local group all 50 plus galaxies, would fit in a room, a region perhaps the size of a large hall. That hall, containing dozens of galaxies and trillions upon trillions of stars, is our local neighbourhood at this scale. It is our small cluster of islands in the cosmic sea. And once again, our position offers no special distinction. T. The Milky Way is one of the two largest galaxies in the local group, which might sound impressive, but the local group itself is utterly ordinary. A small, unremarkable cluster, the kind that exists in vast numbers throughout the universe. We are a significant member of an insignificant group, just as our Sun is an ordinary star, in an ordinary part of an ordinary galaxy. Our galaxy is an ordinary member of an ordinary little cluster, lost among countless similar clusters scattered across the cosmos. It is worth noticing how this pattern repeats at every level we climb. Each scale, we find ourselves a member of some structure, a planet in a solar system, a star in a galaxy in a group, and at each scale we discover that the structure is itself unremarkable, one of an enormous number of similar structures. There is no level at which we suddenly find ourselves at the centre, no scale at which our position becomes important. Pattern simply continues. Ordinary object, in ordinary group, in ordinary larger group, on and on. The entire history of astronomy has been a steady confirmation of this, level after level. Each new discovery pushing us further from any imagined centre. The chain of smallness grows another link. You are on the Earth. The Earth orbits the Sun. The Sun is a grain of sand in the Milky Way. The Milky Way is one of two large galaxies in the local group. Group is a small hall of galaxies adrift in a far larger structure. At each level, the thing that contains us is vaster than the last, and our position within it remains ordinary, off-centre, unremarkable. Keep zooming out. And home keeps shrinking, and we have still not reached anything like the limit, because the local group, too, is not alone, part of something far larger. A vast assembly of galaxy groups and clusters, drawn together across enormous distances, all flowing toward a common gravitational centre. To see it, we must zoom out again by another huge factor until our entire local group becomes a single point in a structure so large it was only recently mapped and named. That structure is our supercluster, and we did not even know we lived inside it until a few years ago, because the local group too is not alone, part of something far larger, a vast assembly of galaxy groups and clusters, drawn together across enormous distances, all flowing toward a common gravitational centre. To see it, we must zoom out again by another huge factor, until our entire local group becomes a single point in a structure so large it was only recently mapped and named. That structure is our supercluster, and we did not even know we lived inside it until a few years ago. As we widen our view beyond the local group, the first thing we encounter is a far larger and richer collection of galaxies than our own modest cluster, the Virgo cluster. It lies at the heart of our cosmic region, and it exerts a gravitational pull that reaches across tens of millions of light years to tug on our own local group. Understanding it is the next step in seeing the truly large-scale structure of the universe and our small place within it. The Virgo cluster is a massive gathering of galaxies, far larger than our local group. While our local group contains a few dozen galaxies dominated by two big spirals, the Virgo cluster contains well over 1,000 galaxies, many of them giant ellipticals and spirals, far larger than the Milky Way. It lies about 50 million light-years away, 20 times farther than Andromeda, and despite that enormous distance, it is so massive that its gravity influences the motion of galaxies across our entire region, including our own. Think about the leap in scale and population. The local group has a few dozen galaxies, Virgo cluster has more than 1,000, and it is just one cluster among many. The universe, it turns out, is organized hierarchically. Stars gather into galaxies, galaxies gather into groups and clusters gather into still larger structures. At each level, the number of objects and the scale of the distances multiply. We have gone from a few dozen galaxies in our local group to over 1,000 in the Virgo cluster, and we are still climbing. The Virgo cluster is so massive that our entire local group is slowly falling toward it, drawn by its immense gravity across 50 million light-years of space. We are being pulled even now toward this great gathering of galaxies, though the pull is gentle and the distance so vast that the journey would take many billions of years. Local group is not an independent island, hosts caught. It is caught in the gravitational web of the largest structure, drifting slowly toward the dense concentration of galaxies at the region's heart. Pull of unseen mass introduces an important idea, that the universe is shaped, on the largest scales, by gravity reaching across almost unimaginable distances. Galaxies and clusters do not sit still. They flow, drawn toward the regions of greatest mass, pulled across tens and hundreds of millions of light years by the accumulated gravity of countless galaxies. We are part of these vast flows, carried along toward distant concentrations of matter, our whole local group drifting in currents that span the cosmos. Consider how slow and how vast these motions are. Our local group is falling toward the Virgo cluster. But the distance is so enormous that even moving at hundreds of miles every second, we would need many billions of years to arrive. Longer than the current age of the universe. Fact, we may never arrive at all. Because, as we will see, the expansion of space is working against these gravitational flows, and in the far future it will win. For now, the picture to hold is one of immense, ponderous movement. Great rivers of galaxies flowing across hundreds of millions of light years, drawn by gravity toward the densest regions, with our own galaxy and its companions caught up in the current like leaves on a slow and mighty stream. This hierarchical structure. Stars in galaxies, galaxies in groups, groups in clusters, clusters drawn toward greater concentrations, is one of the deepest discoveries of modern cosmology. It tells us that the universe is not a random scattering of galaxies, but an organized structure shaped over billions of years by gravity acting across scales we can barely grasp. And it tells us, once again, that our place is not central. We are not at the dense heart of the Virgo cluster, where the great galaxies gather. We are out on its margins, drawn slowly inward from the outskirts, the scale of clusters, just as at every scale before, we find ourselves on the edge, looking in. And here is where the picture becomes truly large. Virgo cluster, massive as it is itself only the central region of a far larger structure. A supercluster, an assembly of many clusters and groups spread across hundreds of millions of light years, all connected by gravity and the great flows of galaxies. Our local group, the Virgo cluster, and countless other groups and clusters are all part of this single colossal structure. And the astonishing thing is that we only recently came to understand its true extent, and to give it a name. So the Virgo cluster shows us the next level of the hierarchy. Over 1,000 galaxies, 50 million light years away, pulling our whole local group toward it. And it points towards something larger still. The supercluster that contains us all. For most of human history, we did not even know this structure existed. It was mapped and named only in recent years. And when astronomers traced its true boundaries, they found that our home galaxy sits within a structure so vast it defies the imagination. They called it Laniakea. we now arrive at one of the most remarkable discoveries in modern astronomy. A structure so large that our entire local group, with its 50 galaxies, is just a tiny speck within it, and yet a structure we did not even know we lived inside until a few years ago. It is our home supercluster, and astronomers have given it a beautiful name. Laniakea, a Hawaiian word meaning immeasurable heaven. Understanding it lifts us to a scale almost beyond comprehension. For a long time, astronomers knew that galaxies gathered into clusters, and that clusters gathered into superclusters. But the boundaries of own supercluster were unclear. Then, a few years ago, a team of astronomers developed a new way of mapping these vast structures. Not by drawing arbitrary lines, but by tracing the flows of galaxies, watching which way they drift under the pull of gravity. They mapped the motions of thousands of galaxies, following the great cosmic currents, to find the natural boundaries of our home structure. And what they found was breathtaking. Our supercluster, Laniakea, is about 520 million light-years across. Sit with that number against everything we have built. The Milky Way is 100,000 light-years wide. Local group is 10 million light-years across. Laniakea spans 520 million light-years, 50 times wider than our local group, and more than 5,000 times wider than our entire galaxy. Within this colossal structure are gathered around 100,000 galaxies, including our Milky Way, our local group, the Virgo cluster, and countless others. 100,000 galaxies. Remember that each galaxy contains hundreds of billions of stars. So Laniakea contains something like 100,000 galaxies, each with hundreds of billions of suns. A number of stars so vast that it has no meaning to the human mind at all. All of these galaxies are bound together, or rather flow together, drawn toward a common gravitational centre, a great concentration of mass that pulls the whole structure inward. We are part of this flow, drifting with our local group toward the heart of Laniakea, swept along in the largest current we have yet encountered. To grasp the scale, consider this comparison. If you shrank the Milky Way, our entire galaxy, 100,000 light-years wide, holding 400 billion stars, down to the size of a single grain of sand, then Laniakea, on that same scale, would stretch out for miles. Our galaxy would be one grain of sand among 100,000 others, scattered across a structure miles wide, and our sun, within that grain of sand, would be far too small to imagine. We have shrunk from a person, to a planet, to a star, to a galaxy that is now itself a grain of sand, in a structure beyond comprehension. Here is the detail that should truly humble us. We did not even know Laniakea existed until recently. For all of human history, through all our science, we lived inside this immense structure. 520 million light-years across, 100,000 galaxies, without knowing it was there, without knowing its shape or its boundaries or its name. Took until just a few years ago for us to map our own cosmic address at this scale. We are so small, and the structure so large, that we are only now beginning to understand the neighbourhood we have always lived in. There is a lovely meaning hidden in the name itself. Laniakea comes from the Hawaiian, and it means immeasurable heaven or immense sky. The astronomers who mapped the structure chose the name to honour the Polynesian navigators who once crossed the vast Pacific Ocean, using only their knowledge of the stars, sailing for thousands of miles across open water, guided by the heavens, into the unknown, puns. There is something fitting in that. We, too, are navigators of a kind, using the light of distant stars to map a vastness we can never physically cross, charting the immeasurable heaven from the deck of a single small world. The name carries both the humility of our smallness and the quiet dignity of our attempt to understand. A reminder that even as the scale overwhelms us, the act of mapping it is itself a kind of voyage, one of the great voyages our species has ever undertaken. So, Laniakea is the supercluster we did not know we lived in. 520 million light-years wide, 100,000 galaxies flowing toward a common centre, and our whole galaxy just one grain of sand within it. The great gravitational centre that pulls Laniakea together has a name and a mystery of its own. Something at the heart of our supercluster is drawing everything toward it. A concentration of mass so great that it shapes the motion of 100,000 galaxies. Astronomers call it the Great Attractor, and for decades it was hidden from view. The heart of our supercluster, Laniakea, lies a mystery, a region of space toward which our entire galaxy, our entire local group, and 100,000 other galaxies are all slowly flowing, drawn by an immense concentration of mass. For decades, astronomers could detect its pull, but could not clearly see what was causing it, and so they gave it a name that captures both its power and its mystery. The Great Attractor is the gravitational anchor of our region of the universe, and we are falling toward it right now. The story of the Great Attractor began when astronomers noticed something strange about the motion of galaxies in our part of the universe. Beyond the general expansion of the cosmos, which carries galaxies apart, there was an additional motion, a flow, as if galaxies across a huge region were all drifting in the same direction, toward a common point. Our own galaxy, it turned out, is moving through space at a remarkable speed, far faster than the expansion of the universe alone could explain. Something was pulling us, and a vast number of other galaxies, toward a particular region of the sky. That region is the Great Attractor. It lies a few 100 million light-years away, in the direction of certain southern constellations, and it represents an enormous concentration of mass, the gravitational centre toward which our whole supercluster flows. Our galaxy is being pulled toward it at a speed of hundreds of miles every second. Right now, as you sit reading this, you and the entire Milky Way are being drawn through space toward the Great Attractor at a velocity that would carry you from one side of the Earth to the other in a matter of seconds. We are not just adrift. We are falling, all of us, toward this distant mass. For a long time, the Great Attractor was frustratingly difficult to study, because it lies in a direction partly blocked by the disk of our own galaxy. When we look toward the Great Attractor, we are looking through the crowded, dusty plain of the Milky Way, which obscures our view of what lies beyond, a region astronomers call the zone of avoidance, because the dust and stars of our own galaxy hide whatever is behind them. So the very thing pulling us was concealed, in part, by our own galactic home standing in the way, time, using techniques that can see through or around the obscuring dust. Astronomers have built up a clearer picture. The Great Attractor appears to be a great concentration of galaxy clusters, an unusually dense region of the universe where many clusters gather, their combined gravity drawing in everything around them, including us. It is not a single object, but a vast accumulation of mass, the densest part of our cosmic region, the bottom of a gravitational valley into which our whole supercluster is slowly sliding. What does this add to our sense of scale and smallness? It tells us that even our motion, the drift of our entire galaxy through space, is not our own, coursed in a current far larger than ourselves, falling toward a mass we can barely see. Hundreds of millions of light-years away, the Sun is carried by the galaxy. The galaxy is carried by the local group. The local group is carried by the flow toward the Great Attractor. At every level, we are swept along by forces vastly larger than anything we could resist or even perceive. We are passengers, not drivers, on a journey we did not choose and cannot feel. there is a final irony in the Great Attractor, one that points ahead to the end of our story. For all its immense pull, for all that it draws 100,000 galaxies toward it across hundreds of millions of light years, it will not win. The expansion of the universe, which we will come to shortly, is accelerating. And in the far future, that expansion will overwhelm even the gravity of the Great Attractor. Flows will slow, then reverse, then cease. As the accelerating expansion carries the distant galaxies away, faster than any gravity can pull them back. The Great Attractor is the dominant force in our region now, the gravitational heart toward which we fall. Foot. But it is fighting a losing battle against the stretching of space itself. Even the greatest concentrations of mass in our cosmic neighborhood are, in the end, no match for the expansion that will scatter everything apart. So the Great Attractor is the hidden engine of our motion, the gravitational heart of Laniakea, pulling 100,000 galaxies toward it across hundreds of millions of light years. And it, in turn, is part of an even grander pattern. For the superclusters themselves are not scattered randomly through space. They are arranged in a vast, intricate structure that spans the entire observable universe, the largest pattern that exists. To see it, we must zoom out one final enormous step until even superclusters become mere threads in a web that fills the cosmos, climbed from the Earth to the Sun, from the Sun to the galaxy, from the galaxy to the local group, to the Virgo cluster, to the supercluster Laniakea, and to the Great Attractor that pulls it all. Now we take the final step in scale, the largest step of all, to see how the superclusters themselves are arranged. Because when astronomers map the positions of galaxies across the entire observable universe, they find that everything is woven into a single vast, intricate pattern, the cosmic web host. It is the largest structure that exists, and within it everything we have discussed is just a knot or a thread. When you map the universe on the grandest scale, plotting the positions of millions of galaxies across billions of light years, a pattern emerges that no one expected. The galaxies are not scattered randomly, like grains of sand thrown across a floor. Instead, they are arranged in long, thin filaments, vast strings of galaxies stretching across hundreds of millions of light years. These filaments cross and connect at great nodes where clusters and superclusters gather. Between the filaments lie enormous empty regions, voids, where there are almost no galaxies at all. The result looks astonishingly like a web or a network of neurons, or the structure of a sponge. Bright filaments of galaxies thread through the darkness, meeting at dense junctions, surrounding vast bubbles of near emptiness. This is the cosmic web. The arrangement of all matter on the largest scales, the skeleton of the universe itself, our supercluster, Laniakea, with its 100,000 galaxies, is just one region of this web, one thick strand among countless others. The web extends in every direction, as far as our telescopes can see, filling the entire observable universe. The scale of the cosmic web is almost impossible to state meaningfully, but let us try. Filaments stretch for hundreds of millions of light years. Voids between them are similarly vast, empty bubbles hundreds of millions of light years across, containing almost nothing. The entire web spans the whole observable universe, which is tens of billions of light years across. Within this web are all the superclusters, all the clusters, all the galaxies, all the stars, all the planets, all the matter that exists. Everything we have ever known or seen is woven somewhere into this single vast structure. And our place within it? We are in a filament, one of the great strands of the cosmic web, but not at a dense, important junction. Supercluster lies along the web, and within it our local group, and within that, our galaxy, and within that, our sun. If you zoomed in on the cosmic web, on the entire arrangement of matter in the universe, and tried to find our sun, you would first have to find our filament among countless filaments, then our supercluster within the filament, then our galaxy within the supercluster, then our sun within the galaxy. We are a speck within a grain, within a knot, within a strand of a web that fills all of creation. There is something profoundly strange and beautiful in the realization that the universe has a structure at all, that on the largest scales, matter is not random but organized, woven into this intricate web by the action of gravity over billions of years. Web grew from tiny ripples in the early universe, regions slightly denser than average, which pulled in matter over cosmic time until they formed the filaments and nodes and voids we see today. The cosmic web is the grandest pattern in existence, the final architecture of all matter, and it took the universe its entire lifetime to build. The origin of this web is one of the most remarkable stories in all of science. When the universe was young, it was very nearly smooth. Matter spread out almost perfectly evenly, with only the faintest variations, regions a tiny fraction denser or thinner than their surroundings. These variations were almost nothing, ripples of less than 1 part in 100,000. But gravity is patient. Billions of years, the slightly denser regions pulled in more matter, growing denser still, while the thinner regions gave up their matter and grew emptier. Slowly, the faint ripples were amplified into the filaments and voids of the cosmic web. The grandest structure in existence grew from the faintest imperfections in the early universe. A reminder that the vast architecture around us was written in seed form into the very first moments of time. The cosmic web is the largest structure that exists, and within it, every galaxy and supercluster is just a thread or a knot. We have reached the top of the ladder of structures. There is nothing larger than the web, because the web is everything, arranged. But we have not quite reached the edge of what we can see, because woven through this web are the great voids, the vast empty bubbles between the filaments. And our journey would be incomplete without understanding them. They are the emptiest places in all of existence, and they make up most of the volume of the universe. We have seen that the cosmic web is made of bright filaments of galaxies, meeting at dense junctions. The web is mostly not filaments. Most of the universe, by volume, is the dark space between the threads, the great voids, enormous empty bubbles where there are almost no galaxies at all. These voids are among the strangest features of the universe, and they hold a humbling lesson about how empty the cosmos truly is. A cosmic void is a vast region of space, hundreds of millions of light years across, that contains almost nothing, where the filaments of the cosmic web are strung with galaxies. The voids are nearly empty. A few lonely galaxies scattered through an immense darkness, separated from one another by distances so great that, from within a void, a galaxy might find almost no neighbours visible at all. Voids are the deserts of the universe, regions where matter is so thinly spread that they are, for all practical purposes, empty. Here is the astonishing thing. The voids make up most of the volume of the universe. If you measured the total space in the cosmos, the great majority of it would be void. Empty bubbles with only a small fraction of the volume occupied by the filaments where galaxies gather. The universe is not mostly galaxies with some gaps. It is mostly gaps, with galaxies confined to thin threads winding between the vast empty spaces, the bright structured parts of the universe. Everything we have discussed are the exception. Emptiness is the rule. Consider what this means for our sense of place. We live in a filament, on a thread of the cosmic web. surrounded by other galaxies in our supercluster. Host. We are in one of the relatively crowded parts of the universe, but just beyond our region, and throughout most of the cosmos, lie these enormous voids where there is almost nothing. Vast bubbles of darkness larger than our entire supercluster, containing only a handful of lonely galaxies. Host. Most of the universe is emptiness on a scale that dwarfs even the immense structures we have explored. There is a particular loneliness to the idea of the voids. Imagine a galaxy in the center of a great void. A galaxy with no close neighbors, surrounded on all sides by hundreds of millions of light years of near-empty space. From within such a galaxy, an astronomer looking out would see very few other galaxies, and those only faintly, impossibly far away. They might even struggle to understand the universe at all. With so little to observe nearby, we are fortunate, in a sense, to live in a filament where there are neighbours to see. A civilization in a deep void might look out and see almost nothing but darkness. This emptiness is a final lesson in the scale of the universe, and perhaps the most humbling of all. Not only are we small, a speck within a grain, within a thread of the cosmic web, but the web itself is a thin tracery of matter strung through an overwhelming emptiness. The universe is not crowded. It is not full. It is overwhelmingly empty. Vast bubbles of darkness, separated by thin threads of galaxies, with all the matter we have ever known confined to those threads. A speck of something, in a thread of something, surrounded by oceans of nothing. And the emptiness goes deeper than even the voids suggest. Consider that the galaxies themselves, the bright threads of the web, are mostly empty too, vast distances between stars, with the stars themselves tiny against the gaps, and the atoms that make up the stars and the planets, and you are mostly empty as well. If you removed all the empty space from within the atoms of a human body, what remained would be smaller than a grain of dust. So the emptiness is not just a feature of the largest scales. It runs all the way down, from the voids between the filaments, to the gaps between the stars, to the spaces within the atoms. The universe is empty at every level. The solid, full world you seem to inhabit is almost entirely empty space. A few specks of matter, vastly separated, held together by forces, giving the illusion of solidity. Emptiness is not just the rule of the cosmos. It is the rule of everything, even you. So the voids show us that the universe is mostly empty, that the structures we have explored are thin exceptions in an overwhelming darkness. We have now seen the full architecture of the cosmos, the web, the filaments, the voids. It is time to step back and take in the total number, the grand sum of everything. How many galaxies are there, all told, in the observable universe? Past. The answer is a number that we have been building toward this entire journey, and it is large enough to break the mind completely. We have built our way up through every level of cosmic structure. Stars, galaxies, groups, clusters, superclusters, the cosmic web. Now it is time to confront the grand total, the number that this entire journey has been leading toward. How many galaxies are there in the observable universe? Not stars, galaxies, each one containing hundreds of billions of stars. The answer is a number so large that it marks, perhaps, the true limit of what the human mind can even pretend to grasp. For a long time, astronomers estimated that the observable universe contained something like 100 billion galaxies. That number alone is staggering. 100 billion galaxies, each with hundreds of billions of stars. As telescopes improved, and astronomers looked deeper into space, peering at fainter and more distant galaxies, the estimate climbed. Deeper they looked, the more galaxies they found, including vast numbers of small, faint, distant galaxies that earlier surveys had missed. And when they accounted for all of these, the number rose dramatically. The current best estimates suggest that the observable universe contains around 2 trillion galaxies. 2 trillion. 2 trillion stars. 2 trillion galaxies, each one a vast island of stars like our Milky Way, each containing on average hundreds of billions of suns. Multiply it out, if you dare. 2 trillion galaxies, times a few hundred billion stars each, gives a number of stars so enormous that it is often said there are more stars in the observable universe than there are grains of sand on all the beaches of the earth. And that comparison, staggering as it is, may even understate the truth. Try to hold the number 2 trillion. We have already seen that you could not count to 6 trillion, the number of miles in a single light year, in 40 times the length of human history. 2 trillion is of the same order. If you tried to count the galaxies, one per second, naming each one, it would take you tens of thousands of years of continuous counting, without sleep, without pause, just to count the galaxies, not the stars within them, just the galaxies themselves. And each one of those galaxies is a Milky Way, or larger, holding its own hundreds of billions of stars, its own giants like Betelgeuse, its own quiet suns like ours, perhaps its own worlds, perhaps its own life. Now place our galaxy within this number, the Milky Way, our home, the city of 400 billion suns, 100,000 light-years wide, so large that light takes 100,000 years to cross it, is one galaxy out of 2 trillion. If the galaxies were grains of sand, our entire Milky Way, with all its hundreds of billions of stars, would be a single grain among 2 trillion grains, a quantity of sand that would fill not a bucket, not a truck, but vast stretches of beach. And our sun is one star among the hundreds of billions in that single grain, and the Earth is a speck circling that one star. And you are a single small being on that speck. This is the number that breaks the mind, not because it is hard to say. 2 trillion galaxies is easy enough to pronounce, but because there is no way to truly feel it. No comparison large enough, no model that can hold it. The human mind evolved to count handfuls of things, to grasp the size of a valley or a herd or a tribe. It was never built to comprehend 2 trillion galaxies, each with hundreds of billions of stars. We can write the number, we can do the arithmetic, but we cannot feel it. It is simply finally too large. It is the point where comprehension fails entirely, where even the cleverest comparison runs out, and we are left simply staring at the number, knowing it is true and knowing we cannot hold it. So there it is, 2 trillion galaxies, and our Milky Way is one of them, and we are a speck on a speck within that one. This is the sum of everything, the grand total of the structures we have climbed through. Every star, every world, every distance we have crossed, gathered into a single staggering number. And yet, even now, we have not quite reached the edge, because all of these 2 trillion galaxies are contained within a single sphere, the observable universe. And that sphere has a size, and an edge, and a strange and wonderful property that we must understand to complete the journey. The sphere is larger than it has any right to be, and its edge is one we can never cross. We have reached the grand total, 2 trillion galaxies. And now we must understand the container that holds them all, the observable universe. This is the sphere of space around us, from which light has had time to reach us. Since the beginning, the totality of everything we can, in principle, see, and its size is one of the strangest and most mind-stretching facts in all of cosmology. The observable universe is a sphere centered on us, not because we are special, but because we can only see in all directions out to a certain distance. The distance that light has been able to travel since the universe began. Beyond that distance, the light simply has not had time to reach us yet. So we sit at the center of a vast sphere of visibility, and everything within it, all 2 trillion galaxies, all the cosmic web, all the matter we can detect, makes up the observable universe. It is quite literally everything we can see. Now, how large is this sphere? You might reason as follows. The universe is about 13.8 billion years old, and nothing travels faster than light, so the farthest we could possibly see is 13.8 billion light years in any direction. That would make the observable universe about 28 billion light years across. It is a reasonable guess, and it is wrong. Not a little wrong, but wrong by more than a factor of 3. The observable universe is far larger than its age in light years would suggest. The actual diameter of the observable universe is about 93 billion light years. The edge lies not 13.8 billion light years away, but about 46 billion light years away in every direction. This seems impossible at first. How can we see something 46 billion light years away if light has only had 13.8 billion years to travel? How can the universe we observe be larger than the distance light could have crossed in its entire lifetime? Lost. The answer lies in one of the deepest features of the cosmos, and it is the key to understanding the true size of everything. The answer is that space itself has been expanding. The universe is not static, it has been growing, stretching, ever since the Big Bang. When light left a distant galaxy 13 billion years ago and began travelling toward us, the space between us and that galaxy was expanding the whole time the light travelled. The light covered the distance, but meanwhile the distance itself was growing. By the time the light reaches us today, the galaxy that emitted it has been carried far, far away by the expansion of space, to a present distance of tens of billions of light years, even though the light only travelled for 13 billion years. This is why the observable universe is 93 billion light years across, even though it is only 13.8 billion years old. The expansion of space has stretched the distances, carrying the most distant galaxies far beyond where they were when their light set out. We are seeing them as they were in the distant past, but they are now much farther away than the simple light travel time would suggest. The size of the observable universe is not just about how far light has travelled. It is about how much space has stretched while the light was on its way. Worth pausing to absorb how counterintuitive this is, because it overturns one of our most basic assumptions about distance. In ordinary life, if something is a certain distance away, it stays that distance. The wall across the room does not drift farther as you look at it, but on cosmic scales, distance is not fixed. The galaxies whose light reaches us tonight were relatively close when that light departed. But space itself has stretched in the intervening billions of years, carrying them ever farther away. Galaxy, whose ancient light we now see, may be, at this moment, 46 billion light years away, and still receding. We are not seeing where it is. We are seeing where it was. While its true present position lies far beyond anything we could ever observe, distance in the expanding universe is not a fixed fact, but a moving target, stretched by the growth of space itself. So the observable universe is a sphere 93 billion light-years wide, centered on us, containing 2 trillion galaxies, woven into the cosmic web, mostly empty void, with our Milky Way as a single grain somewhere within it. This is the full extent of everything we can see, the largest scale there is, the container of all the structures we have climbed through. And yet this enormous sphere raises one final dizzying question. Space has been expanding, and the edge is 46 billion light-years away. What does that edge actually mean? Can we ever reach it? And what lies beyond it? The answers are stranger than the size itself. We We have just encountered something that sounds like a contradiction. The universe is 13.8 billion years old. Yet, we can see objects whose present distance is 46 billion light years away. This deserves a closer look because it reveals something profound about the nature of space itself. Something that overturns our ordinary intuitions about distance, motion, and the speed of light. Our everyday intuition says that nothing can travel faster than light, and that therefore in 13.8 billion years, nothing could have gotten farther than 13.8 billion light years away. This intuition is correct as far as it goes. Nothing can travel through space faster than light, but it misses the crucial point. The distant galaxies are not moving through space to get away from us. Space between us and them is expanding, carrying them along. The expansion of space itself is not limited by the speed of light. This is the key idea, and it is worth stating carefully. The rule that nothing can exceed the speed of light applies to objects moving through space. A spaceship, a particle, a beam of light does not apply to the expansion of space itself. Space can stretch as fast as it likes. There is no speed limit on the growth of space. Two galaxies, sitting still in their own regions of space, can be carried apart faster than light, simply because the space between them is expanding so rapidly. They are not moving through space faster than light. The space between them is growing faster than light can cross it. Picture it this way. Imagine ants standing still on the surface of a balloon, and then imagine the balloon being inflated. The ants are not walking. They are stationary on the rubber, but as the balloon expands, the distance between any two ants grows, and ants that are far apart on the balloon separate faster than ants that are close together. If the balloon is large enough and inflating fast enough, two distant ants could be carried apart faster than either of them could ever walk. Not because they are moving, but because the surface beneath them is stretching. The galaxies are like those ants, carried apart by the stretching of space. This expansion has been happening for the entire history of the universe, and it explains how we can see farther than light could have travelled in a static cosmos. When the light from a distant galaxy began its journey toward us, the galaxy was relatively close, but as the light travelled, space expanded, stretching the distance. The light kept moving toward us at its fixed speed, but the finish line, us, was being carried farther away by the expansion, even as the starting point fell behind. After 13 billion years, the light finally arrives. But the galaxy that sent it is now tens of billions of light years away, carried off by the expansion. There is a further, stranger consequence, because space is expanding, and the most distant galaxies are being carried away faster than light. There are galaxies whose light will never reach us. Galaxies so far away that the space between us is growing faster than their light can cross it. We can see them now, as they were long ago, but the light they emit today will never arrive, because the expansion will carry them beyond our reach before it can. The observable universe, in this sense, is not just large, it is bounded by the expansion itself, with a frontier beyond which things are receding too fast to ever be seen. This idea takes some getting used to, because it means there is a fundamental limit built into the cosmos. Not a limit of technology, but a limit of physics itself. No matter how powerful our telescopes become, no matter how long we wait, there are regions of the universe whose light can never reach us, because the space between us and them is stretching faster than light can cross it. They are not hidden behind some obstacle we might someday see around. They are causally disconnected from us, forever beyond any possible contact. They might as well be in another universe entirely. for all the difference they can ever make to ours. The expanding cosmos does not just make the universe large, carves it into regions that can never communicate. Islands of space sealed off from one another by the relentless growth of the void between them, so we can see farther than the universe is old, because space has been stretching the whole time, carrying the distant galaxies far beyond the simple light travel distance. The observable universe is 93 billion light-years across, not because light has travelled that far, but because space has expanded that much while the light was on its way. This is one of the deepest truths about the cosmos, that space is not a fixed stage but a stretching fabric, and it leads us to the strange nature of the edge of the observable universe. A boundary, unlike any other, which we can never cross. The observable universe has an edge. A boundary 46 billion light-years away in every direction, beyond which we cannot see. But this edge is unlike any boundary in ordinary experience. It is not a wall, not a barrier, not a physical limit. It is a horizon, and understanding what kind of edge it is reveals one of the most humbling truths about our place in the cosmos. That there is a limit to what we can ever know, built into the very structure of space and time. First, let us be clear about what the edge is not. It is not a wall or a boundary in space, like the edge of a room or the shore of an ocean. If you could somehow travel to the edge of the observable universe, you would not find a barrier. You would find more galaxies, more space, more universe stretching on. The edge is not out there as a physical thing. It is, instead, a horizon, the limit of how far we can see from here, set by the distance light has been able to travel since the beginning. It is like the horizon at sea, not a wall, but the limit of your view which moves as you move. The edge of the observable universe is sometimes called the cosmic horizon, and the comparison to a horizon is exact. When you stand on the ocean and look out, you can see only so far before the curve of the earth hides the rest. That is your horizon. But the ocean does not end there. It continues beyond, out of sight. The cosmic horizon is the same. It is the limit of our view, set by the finite speed of light and the finite age of the universe. But the universe continues beyond it, out of sight, perhaps forever. We see a sphere 93 billion light-years wide, but that sphere is just the part we can see, not the whole of what exists. Now, here is the truly humbling part. We can never cross this edge. We can never reach the galaxies at the cosmic horizon, and we can never see beyond it. This is not because of any limitation of our technology, but because of the expansion of space itself. Most distant galaxies are receding from us faster than light, carried away by the expansion, so we could never catch up to them, never travel to them, never reach the edge. Worse, the expansion is accelerating. Over time, more and more galaxies will be carried beyond our horizon, lost to us forever, their light stretched and dimmed until it fades from view. This means that the observable universe is not only bounded, but in a strange sense, shrinking, not in size, but in content. The expansion accelerates. Galaxies that we can see today will eventually be carried beyond our horizon, their light no longer able to reach us, stretched and dimmed until it fades entirely from view. In the far future, the observable universe will contain fewer and fewer visible galaxies. As the cosmos spreads itself thinner and the distant lights wink out one by one, we live, it turns out, in a privileged time when we can still see 2 trillion galaxies. Future inhabitants of our galaxy, in the distant ages to come, will see far fewer as the rest recede slowly beyond reach. There is a profound humility in this. We tend to assume that, given enough time and technology, we could explore the whole universe, reach any place, see anything. But the expansion of space says otherwise. There is a fundamental, permanent limit to what we can ever reach or even see. A horizon built into the structure of the cosmos, beyond which lies a universe we can never touch, never visit, never know. We are confined forever to our own observable bubble, a sphere of visibility in an unknowable larger whole. The edge is not a wall we might someday breach. It is a limit woven into reality itself. So the edge of the observable universe is a horizon we can never cross. Not a wall, but a limit of vision and of reach, set by the finite speed of light and the relentless expansion of space. Beyond it lies more universe, forever hidden from us, continuing on past the limit of everything we can ever know. And this raises the final question of scale. If there is more universe beyond what we can see, how much more is there? What lies past the edge? The honest answer is one of the most important and humbling things science can say. And it points us back, at last, toward the question of our own smallness, and what it really means. We have reached the edge of the observable universe. The cosmic horizon, 46 billion light-years away, beyond which we cannot see. But we have also learned that this edge is not the edge of the universe itself, only the edge of the part we can observe. So the natural question, the one that has perhaps been forming in your mind throughout this journey, is this what lies beyond? How much more universe is out there, past the horizon? The answer reveals both the limits of human knowledge and the true, possibly infinite, scale of everything. The honest answer is that we do not know. And in a deep sense, we cannot ever know. The region beyond the cosmic horizon is, by definition, the part of the universe whose light has not reached us, and never will. We have no way to observe it, no way to measure it, no way to gather any direct information about it at all. It lies permanently beyond our reach, hidden by the finite speed of light and the relentless expansion of space. Whatever is out there, we are cut off from it forever. This is one of the rare cases where science must say, clearly and humbly, this is something we simply cannot know. But while we cannot observe beyond the horizon, we can reason about it. And the reasoning suggests that the universe extends far beyond what we can see, possibly infinitely far. The observable universe shows no sign of an edge or a center. Everywhere we look, in every direction, we see the same kind of structure. Galaxies, clusters, the cosmic web, spread out roughly uniformly. There is no indication anywhere that we are near any boundary. No sign that the universe thins out or stops somewhere just beyond our view. The simplest interpretation is that the universe continues beyond the horizon, much the same as within it, on and on. How far does it continue? Here the possibilities become staggering. Some lines of reasoning suggest the universe is vastly larger than the observable part, perhaps hundreds or thousands of times larger, perhaps far more than even that. Other lines of reasoning suggest it may be infinite, truly without end, extending forever in all directions, containing an infinite number of galaxies, an infinite amount of matter, an infinite expanse of space. We do not know which is true, and we may never know, but in every scenario, the observable universe, that sphere 93 billion light-years wide, with its 2 trillion galaxies, is only a small part, perhaps an infinitesimal part, of the whole. Let that settle, because it is the final expansion of scale on this journey, thing we have climbed through. The Earth, the Sun, the galaxy, the local group, Laniakea, the cosmic web, the 2 trillion galaxies. All of it fits inside the observable universe, and the observable universe may itself be just a tiny fraction of a far larger, possibly infinite cosmos, the rest of which we can never see. 2 trillion galaxies we can observe might be a vanishingly small sample of an endless ocean of galaxies, stretching beyond our horizon in every direction, on and on, forever. The number that broke the mind, 2 trillion, might be against the true total, essentially zero. And if the universe is infinite, the consequences are almost beyond contemplation. In an infinite universe, with an infinite number of galaxies and stars and worlds, anything that can happen happens somewhere, an infinite number of times. There would be no limit to the number of stars, the number of worlds, the number of possibilities. Our entire observable universe, vast beyond comprehension, would be a single drop in an infinite sea. We cannot confirm this. It lies beyond what we can ever know. But it is a real possibility, and it represents the ultimate horizon of scale, the point where even the largest number we could name becomes nothing against the infinite. So what lies beyond the edge is, in the end, unknowable, but reasonably believed to be vastly more universe, possibly infinite, of which our observable sphere is only a tiny part. We have reached the limit not just of what we can see, but of what we can know, the outer boundary of human comprehension itself. And here, at this ultimate boundary, the journey of scale is complete. We have climbed all the way from your chair to the possibly infinite cosmos. And at every single step, we have grown smaller. Now it is time to turn from the size of space to the size of time. Because our smallness is not only spatial, we are small in the story too, not just in the space. We have explored the size of the universe in space, and found ourselves almost infinitely small within it. But there is another dimension in which we are equally small, and which we have only touched on so far. Time. The universe is not only vast in space, it is vast in time, stretching across billions of years, and within that immense span, the entire existence of humanity is a flicker so brief it can barely be measured. To complete our sense of scale, we must feel our smallness in time as well as in space. The universe is about 13.8 billion years old. That number, like the spatial distances, is almost impossible to feel, so let us put it on a scale we can grasp. Imagine compressing the entire history of the universe, all 13.8 billion years, into a single calendar year, with the Big Bang on January the 1st and the present moment at midnight on December the 31st. On this cosmic calendar, where would the events we care about fall? The answer is humbling beyond words. On this cosmic calendar, the Big Bang is January 1st. Our own solar system and the Earth do not form until late August or early September. The universe is already 2/3 old before our sun even exists. Life appears on Earth in the autumn. But for most of the year it remains simple, microscopic. Complex life does not flourish until December. The dinosaurs appear around Christmas and are wiped out on the 30th of December. And human beings. All of recorded human history, every civilization, every person who has ever lived, appear only in the last few seconds before midnight on December the 31st. Sit with that. If the history of the universe were a single year, all of human history, the pyramids, the empires, every war, every discovery, every life, would occupy the last few seconds before midnight. Your own life, your 70 or 80 years, would be a fraction of the final fraction of the last second. We are not just small in space, a speck on a speck within 2 trillion galaxies. We are small in time, a flicker in the final instant of a year-long story that has been unfolding for 13.8 billion years before we arrived. Future stretches just as far or farther. The universe is not near its end. In many ways it is still young. The stars will continue to shine for trillions of years. Cosmos has a future ahead of it so long that the 13.8 billion years that have passed so far are only the opening chapter. We are very early in the universe's story, in its bright morning, and we exist for only a flicker of that morning before passing on. The universe will continue, vast and indifferent, for an almost unimaginable span after we are gone. This smallness in time mirrors our smallness in space, and together they complete the picture. We are tiny in extent, a speck within 2 trillion galaxies, within a possibly infinite universe. We are tiny in duration, a flicker within 13.8 billion years, with trillions more to come, both space and time. The universe is vast beyond comprehension, and we are vanishingly small within it. This is the full weight of our smallness, the complete picture that this journey has been building toward. It is, perhaps, enough to make anyone feel like nothing at all. It is worth feeling how the two kinds of smallness reinforce each other, because together they are heavier than either alone. It is one thing to be small in space, a speck on a speck, lost among the galaxies. It is another to be small in time, a flicker, gone almost as soon as it appears. But to be both at once, a tiny point of brief awareness in an immensity of space and an eternity of time, is the full measure of the human situation. Your entire life, everything you will ever do, everyone you will ever love, every thought you will ever think, occupies a vanishingly small region of space for a vanishingly brief moment of time, in a universe that is unimaginably larger and older and longer lived than you in every direction. This is not a comfortable thought. It is, however, an honest one, and we have arrived at it fairly by looking clearly at the facts. But before we sit with that feeling, and we will sit with it honestly, there is one more aspect of our smallness in time worth feeling directly, because the vastness of time is not just an abstraction. It is written into the very light we see when we look up at the night sky. Point of light up there is a message from the past, and some of those messages are older than the earth itself. To look at the stars is to look into deep time, directly, with your own eyes. We have spoken several times on this journey about how light takes time to travel, and how looking out into space means looking back into time. Now, near the end, let us bring that idea fully home, because it is not an abstraction. It is something you can experience directly, tonight, with your own eyes. Point of light in the night sky is a message from the past. And when you understand this, the simple act of looking up becomes a journey through deep time. Go outside on a clear night and look up at the stars. Each one is a sun, and each one is at a different distance, which means each one shows you light from a different moment in the past. The light from a nearby star left it a few years ago. The light from a distant star left it thousands of years ago. So when you look at the sky, you are not seeing a single moment. You are seeing many different pasts at once, layered together. A few years ago here, 1,000 years ago there, all mingled in the same dark dome above you. Consider the bright stars you can name. When you look at a star 100 light years away, you are seeing light that left it a century ago. Light that began its journey before you were born, perhaps before your grandparents were born. When you look at Betelgeuse in the shoulder of Orion, you are seeing light that left it around 700 years ago, in the time of the late Middle Ages. The star you see tonight is the star as it was then. What it is doing now, you will not see for another 700 years. You are looking at a 700-year-old picture hanging in the sky. And when you find that faint smudge of Andromeda, the nearest large galaxy, you are looking at light that left it 2.5 million years ago. Light that began its journey before modern humans existed, when our ancestors were still early, primitive forms. That ancient light crossed 2.5 million years of space and time to enter your eye tonight. You are seeing a galaxy not as it is, but as it was before your species existed. The past is not gone. It is still arriving, still visible, written in the light that reaches us across the vastness. This is perhaps the most direct way to feel deep time. You do not need a telescope or a calculation. You only need to look up and understand what you are seeing. The night sky is a museum of the past, each light a different age, the farthest ones older than the earth. Some of those lights, as we have said, may be ghosts. Stars that have already died, whose final light is still crossing the gulf toward us. When you look up, you are seeing a universe that no longer exists in that form, a recording of moments long past, still playing out in the light that reaches your eyes. There is something both humbling and intimate in this vastness of space and time, which can feel so abstract and overwhelming, is right there above you every clear night, accessible to anyone who looks up and understands. You, standing on your small patch of ground, can look up and see across millions of years, can witness light that began its journey before you, before your species, before your planet. Deep time we have been discussing is not somewhere far off. It is overhead every night, waiting to be seen. You are connected, by light itself, to the deep past of the cosmos. The same photons that left those distant stars and galaxies, crossing the dark for years or centuries or millions of years, end their long journey in your eye. A direct, physical link between you and the ancient universe, completed in the moment you look up. So the light you see tonight is truly a message from the past. A direct personal experience of the deep time and vast space we have explored and this brings us at last to the heart of the matter, climbed through all the scales of space and time, and at every step we have grown smaller, until now we stand as a flicker on a speck, gazing at ancient light from a vanishingly small corner of a possibly infinite cosmos. It is time to face the feeling this journey was always going to produce, the feeling of being nothing at all. First, let us understand the force that is slowly carrying all those lights away from us, dimming the sky over the vastness of time. Before we turn inward to face the feeling of our smallness, there is one more cosmic process we must understand, because it shapes the ultimate fate of everything we have seen. The universe is not static. It is expanding. And not only expanding, but expanding faster and faster, pulling the galaxies apart, slowly carrying the lights of the cosmos away from one another. This expansion is the engine of the universe's future, and it is steadily, silently, pulling it all apart. We have already touched on the expansion of space. It is what makes the observable universe larger than its age in light years, and what places galaxies beyond our horizon. But let us understand it more fully now, for since the Big Bang, space itself has been stretching, carrying the galaxies apart from one another. The galaxies are not flying through space like debris from an explosion. Rather, the space between them is growing, so that every galaxy sees all the others receding, as if it were at the centre. It is the fabric of the cosmos itself that is expanding, everywhere, all at once. For a long time, astronomers assumed that this expansion must be slowing down. After all, the galaxies pull on one another with gravity, and gravity should act as a brake, gradually slowing the expansion over time. When astronomers actually measured the expansion, they found something shocking. It is not slowing down. It is speeding up. The expansion of the universe is accelerating, the galaxies flying apart faster and faster as time goes on. Something is pushing the universe apart, overcoming gravity, driving the acceleration. We do not know what it is, so we have given it a name: dark energy. Dark energy is one of the deepest mysteries in all of science. It makes up most of the energy in the universe, and yet we do not know what it is. We know only its effect. It pushes space apart, driving the accelerating expansion, growing more dominant as the universe expands and the galaxies thin out. Space stretches. There is more space, and so more dark energy, and so more push. A runaway process that will, over the vast future, carry the galaxies apart ever faster until the cosmos is stretched thin and cold and empty. What does this mean for the future of the sky? The immense spans of time ahead, the accelerating expansion will carry distant galaxies beyond our horizon. One by one, their light stretched and dimmed until it fades from view. 2 trillion galaxies we can see today will gradually disappear, receding faster than their light can reach us, until the observable universe contains only our own local group of galaxies, isolated in an ever-growing darkness. The rich, crowded cosmos we see now is a feature of this early epoch. In the far future, the sky will be nearly empty. There is a strange poignancy in this. We live at a privileged moment, when the universe is still young enough, still compact enough, that we can see 2 trillion galaxies, can map the cosmic web, can know the true scale of everything. Future astronomers, in the distant future, will look out and see only darkness beyond their own galaxy, with no way to know that 2 trillion others ever existed. The evidence of the universe's true size will have receded beyond reach. We are among the fortunate, able to see the cosmos in its fullness, before the expansion carries it away. This is a remarkable and sobering thought, if intelligent beings arise in the far future, tens or hundreds of billions of years from now, and look out at their sky, they will see only their own galaxy, isolated in an apparently empty void. They will have no way to discover the expansion, no way to detect the other galaxies, no way to reconstruct the history of the Big Bang, because all the evidence will have been carried beyond their horizon. They might reasonably conclude that their single galaxy is the entire universe, eternal and alone, truth we have worked so hard to uncover. The 2 trillion galaxies, the cosmic web, the expanding cosmos, will be permanently lost to them, erased not by any catastrophe, but by the simple, relentless stretching of space. We happen to live in the brief window of cosmic history, when the full story is still readable. That is a kind of fortune almost too large to comprehend, so the expansion is slowly pulling it all apart, accelerating under the push of dark energy, destined over the vast future to thin the cosmos into cold and empty darkness. This is the ultimate fate written into the universe's structure, and it sets the stage for the final movement of our journey. We have seen the full size of the universe in space and in time, and the force that will eventually scatter it. Now at last we must turn inward and face the feeling that all of this was bound to produce. The weight of being so small, so brief, so utterly insignificant against the vastness. We must face the feeling of being nothing. Before we turn fully inward, let us follow the expansion to its conclusion, and look at the ultimate fate of the universe. The far, far future, when the processes we have described have run their course. Understanding where it is all heading adds the final dimension to our sense of scale. Not just how vast the universe is now, but how it will end, over spans of time that dwarf even its current age. The picture of that ending is one of profound and beautiful desolation. We have seen that the expansion is accelerating, carrying the galaxies apart. Follow this forward, across hundreds of billions and trillions of years, and the consequences unfold inexorably. First, the distant galaxies recede beyond our horizon, vanishing from view, until only our own local group remains visible, isolated in darkness. Then, over far greater spans, the stars themselves begin to die. Stars burn their fuel and fade. Stars form from the leftover gas. But the gas runs out eventually, and star formation ceases. One by one, across trillions of years, the stars wink out. After the last stars die, the universe enters a long, dark era. The galaxies, no longer lit by stars, fade into darkness. Vast collections of dead stars, cold cinders, and drifting matter, growing ever colder and more isolated as the expansion continues. Black holes at the centres of galaxies grow, swallowing what remains, and then, over spans of time, so long they make the current age of the universe seem instantaneous, even the black holes slowly evaporate, releasing their energy back into the void. The universe drifts toward a state of cold, dark, featureless emptiness. This ultimate fate is sometimes called the heat death of the universe, a state in which all the energy is spread out evenly. No structures remain, no stars shine, no processes occur. Cosmos becomes a cold, dark, empty expanse, stretched ever thinner by the relentless expansion, drifting toward a final equilibrium of nothingness. It is the ultimate destination implied by the laws we understand. Not a bang, not a collapse, but a slow fading into cold and dark and silence, over spans of time almost beyond contemplation. Timescales involved are staggering, beyond anything we have discussed. Current age of the universe, 13.8 billion years, is nothing against the spans of the far future. Stars will shine for trillions of years. The dark era that follows will last vastly longer. The evaporation of black holes will take spans of time, written with more zeros than there are atoms in a galaxy. Against these timescales, the entire bright, structured, star-filled epoch we live in, the age of galaxies and stars and life, is the briefest opening flicker, a momentary blaze of light at the very beginning of an almost infinite darkness. And this places our own existence in the starkest possible perspective. We live not only in a tiny corner of space, but in a brief, bright moment of cosmic time. The early epoch when stars still shine, when galaxies still gather, when the universe is still young and full of light. This moment will pass, the light will fade. The cosmos will grow dark and cold and empty, and remain so for spans of time beyond all comprehension. We are a flicker of awareness in the brief morning of a universe destined for endless night. That is the full and final scale of our smallness in space and in time and in fate. And yet, even here, at the contemplation of the universe's cold and distant end, there is a quiet thought worth holding. The heat death lies almost unimaginably far in the future. So far that the entire current age of the universe is less than a blink against it. The darkness is coming, but it is not here, and it will not be here for spans of time that make all of human history, all of life on Earth, all of the age of stars seem like a single bright instant. We live now in the age of light, when the stars shine and a small world circles an ordinary sun, warm enough for beings to arise who can look up and wonder. Darkness is the universe's destiny, but the light is its present, and we are here now in the light. That is not nothing. So the far future is darkness and emptiness, the slow fading of all light, the ultimate scattering of everything by the relentless expansion. Now seen the whole arc, the full size of the universe in space, the full span of its time, and its ultimate cold and empty fate. And against all of this we are small beyond words, a speck, a flicker, a momentary spark in an indifferent vastness. It is time at last to face the feeling this journey was always going to produce. It is time to sit with the weight of feeling like nothing. We have reached the end of the outward journey, climbed from your chair to the edge of the observable universe, and beyond through space and through time, all the way to the cold and empty far future. And now we must turn inward and face the feeling that all of this was always going to produce, the feeling that the title of this journey named from the start. Against the true size of the universe, you feel like nothing. Let us not flinch from that feeling. Let us sit with it honestly, and feel its full weight before we ask whether it is the whole truth. The feeling is this: you are one person on one planet circling one ordinary star in the suburbs of one galaxy among 2 trillion, in an observable universe that is itself perhaps an infinitesimal part of a possibly infinite whole. You exist for a few decades. A flicker in the final instant of a 13.8 billion year story, in the brief bright morning of a cosmos destined for endless dark. By every measure of size and duration, you are vanishingly, almost incomprehensibly small. The universe is vast beyond all feeling, and you are a speck within a speck within a speck. How could you feel anything but like nothing? This feeling has a name and a long history. People have called it the sense of cosmic insignificance. The vertigo that comes from truly grasping the scale of the universe and your tiny place within it can be genuinely disturbing. It can make human concerns, your worries, your ambitions, your relationships, your very existence seem pointless, absurd, swallowed up by the indifference of a cosmos that is unimaginably larger and older than anything human. If the universe is this vast, and we are this small, then what could any of it possibly matter? It would be dishonest to pretend this feeling is not real, or that it can be easily waved away. The scale is real. The numbers are real. Our smallness is not an illusion or an exaggeration. It is a literal, measurable fact. We are, in the most concrete sense, almost nothing against the size of the universe. Any honest reckoning with the cosmos must include this: the genuine, vertiginous smallness of the human being against the vastness of everything. To feel like nothing when confronted with this scale is not a mistake. It is a reasonable response to a true fact. There is a particular weight to feeling this at night, alone, looking up. The sky that once seemed like a comforting dome, a ceiling over a human world, becomes instead a window onto an abyss, depth, beyond depth, light from the unreachable past, an emptiness that goes on forever. The ground beneath you, which felt so solid, is revealed as a tiny moving platform in an infinite dark, the certainties of ordinary life. That you matter, that your world is significant, that you are somewhere near the centre of things, all dissolve against the immensity. It can feel like falling, like vertigo, like being lost. So let us not rush past this. If you have ever looked up at a truly dark sky, full of stars, and felt suddenly small, felt the vastness press down on you, felt your own life shrink to nothing against it, then you have felt something true. The universe is that large. You are that small. This journey has shown, step by step, exactly how true it is. Weight of feeling like nothing is the honest weight of the facts. Crowds. We have earned this feeling fairly by looking clearly at the size of things, and there is no use pretending the feeling away with easy comfort. Some responses to cosmic smallness are too cheap to be honest. That you matter anyway, offered without really facing the scale that prompts the doubt. We will not do that here. Spent this entire journey looking clearly and unflinchingly at how vast the universe is and how small we are within it. And we will not now retreat into comforting words that ignore everything we have seen. Whatever meaning we find, if we find any, has to be a meaning that survives the full weight of the facts, that can be held at the same time as the 2 trillion galaxies and the 13 billion years and the cold and empty far future. Anything less would be a lie, and you would feel it as one. But here is where we must pause and turn the question over, because the feeling of being nothing, real as it is, rests on a hidden assumption. The assumption that size is the same as significance, that to be small is to be meaningless. That assumption, when we examine it closely, turns out to be far less obvious than it seems. Facts of our smallness are not in doubt. What those facts mean, whether smallness truly equals nothingness, is a question the numbers alone cannot answer, and it is to that question that we now finally turn. We have sat with the feeling of being nothing, and acknowledged that our smallness is real, a literal, measurable fact. Now let us examine the assumption hidden inside that feeling. The idea that to be small is to be meaningless, that size and significance are the same thing. Because when we look at this assumption closely, it begins to come apart. The universe is vast, and we are tiny. But it does not follow as cleanly as it seems that we are therefore nothing. Consider, first, that size and importance are not the same kind of thing at all. The universe is large, yes, but largeness is just a quantity of space. Vast cloud of gas is larger than a human being, but no one would say it matters more. Mountain is larger than a person, but the mountain does not think, does not feel, does not love or wonder or know that it exists. Size measures how much space something takes up. It does not measure worth or meaning or significance. To assume that the biggest things are the most important is to confuse two completely different ideas. The cosmos is vast, but vastness alone is not a virtue. Now consider what you are, despite your smallness. You are not a cloud of gas or a lump of rock. You are a conscious being, a small region of the universe that has somehow become aware of itself. You can think, feel, remember, imagine, love, and wonder. You can look up at the 2 trillion galaxies and comprehend, at least a little, what you are seeing. As far as we know, this capacity, awareness, understanding, the ability to ask what it all means, is extraordinarily rare in the universe. Most of the cosmos, vast as it is dead. Gas and rock and empty space, unaware of itself. You are something the mountain and the galaxy are not. You are awake. This is the great reversal, and it is worth stating plainly. The universe is vast, but it does not know that it is vast. It is old, but it does not know that it is old. It contains 2 trillion galaxies, but it cannot count them, cannot wonder at them, cannot feel awe at its own immensity. Only conscious beings can do that. And so, in a strange and profound sense, the universe needs beings like us in order to be known at all. Size of the cosmos is meaningless without someone to measure it. Beauty of the stars is unseen without eyes to look up. We are small, but we are the part of the universe that can comprehend the rest. There is something else. The very fact that we can feel small, that we can grasp the scale of the universe and feel humbled by it, is itself a remarkable achievement. A creature that could not comprehend the cosmos would not feel small before it. It would feel nothing at all. Feeling of cosmic insignificance is, paradoxically, a sign of cosmic significance. It means you have understood something vast, held it in your mind, and responded to it. Galaxy feels small. No star is humbled by the size of the universe. Only a mind can do that. Your ability to feel like nothing is itself. Evidence that you are something rather remarkable, and consider the improbability of your existence. For you to be here, the universe had to produce galaxies and stars and the heavy elements forged in stellar furnaces, and a stable planet, and the long, unbroken chain of life stretching back billions of years, and finally a conscious being capable of asking these very questions. Every atom in your body was made inside a star that lived and died before the sun was born. You are made of stardust, assembled by the universe over billions of years, into something that can look back at the stars and understand where it came from. That is not nothing. That is one of the most extraordinary things the universe has ever done. So smallness is not the same as meaninglessness. Facts of our scale are real. But the conclusion that we are therefore worthless does not follow. We are small in space and brief in time. And we are also conscious, aware, capable of love and wonder and understanding, made of stardust, able to comprehend the very cosmos that dwarfs us. The size of the universe does not erase these things. Anything. It makes them more precious, more improbable, more worth cherishing. And this leads us to the final turn of our journey, the recognition of what we truly are against the vastness. Not nothing. Something far stranger and far more wonderful. We have come to the end of the journey. We began in your chair, feeling still and certain and central, and we have travelled outward through every scale of space and time, past the moon and the sun, past the giants and the galaxy, past the clusters and superclusters and the great cosmic web, to the edge of the observable universe and beyond, into the deep past and the far future, and the possibly infinite whole. And we have faced the feeling this journey was always going to produce, the feeling of being nothing at all. Now, at the end, let us gather what we have found, and arrive at the truth that this feeling concealed. Facts are not in doubt. You are small, almost incomprehensibly small, speck on a speck within 2 trillion galaxies, a flicker in the final instant of a 13 billion year story, a momentary spark in the brief bright morning of a cosmos destined for endless dark. The universe is vast beyond all feeling, and you are tiny within it. This journey has shown, step by careful step, exactly how true that is. If you feel small, you have understood correctly. The smallness is real. Here is what the smallness conceals. The truth we uncovered at the last. You are not just a speck. You are a speck that knows it is a speck. You are a small region of the universe that has woken up, become aware of itself, and turned to look back at the whole. You are the part of the cosmos that can comprehend the cosmos, that can measure the distance to the stars, map the cosmic web, count the galaxies, trace the history back to the beginning. The universe is vast, but it cannot know its own vastness. You can. You are the universe looking at itself, and understanding at last a little of what it is. Think of what that means. Every number in this journey, the distance to the moon, the size of the sun, the width of the galaxy, the count of 2 trillion galaxies, the age of the cosmos. Every one of these was worked out by small, brief, fragile, conscious beings looking up from a speck of rock, using nothing but their minds and the instruments they built. The universe did not hand us this knowledge. We assembled it, piece by piece, across generations, from faint points of light crossing billions of years to reach our eyes. That a creature so small, on a world so tiny, could come to understand the true size of everything. That is, by any honest measure, the most remarkable fact in the entire story. So, when you go outside tonight and look up at the stars and feel that familiar smallness press down on you, hold on to both truths at once. Yes, you are small. A speck beneath an indifferent vastness, gazing at ancient light from a universe that does not know you are there. But you are also the one looking. Psst. You are the eye the universe opened to see itself, the mind it grew to understand itself, the small bright awareness in which all that vastness becomes known. The galaxies do not know they are beautiful. The stars do not know they are vast. Only you and beings like you can look up and know that knowing is not nothing. It may be the most precious thing the universe contains. And here is perhaps the gentlest truth of all, the one to carry with you when the rest fades. Vastness we have explored does not diminish the things that fill your small life. It frames them. Fact that you are a brief flicker in an immense cosmos does not make your loves, your friendships, your quiet, ordinary days less real. If anything, it makes them more precious, because they are rare and fleeting and yours, in a universe that is mostly cold and empty and dark. The 2 trillion galaxies do not compete with the people you care about for significance. They are simply the vast and beautiful stage on which Your small, warm, improbable life is briefly playing out. To be small does not mean your life does not matter. It means your life is a rare and precious thing, lit against an enormous dark. The universe is vast and you are small. Both of these are true, and neither one cancels the other. You are a tiny, brief, fragile thing, and you are the part of the cosmos that turned around and measured itself, that looked into the abyss and comprehended it, that felt the weight of the vastness and, in feeling it, proved itself to be something the vastness can never be. Awake, aware, and full of wonder. True size of the universe might make you feel like nothing, but the truth is stranger and kinder than that. You are not nothing. You are the universe knowing itself for a little while under the light of 2 trillion galaxies. Perhaps is enough for tonight.